Everybody, welcome to Living with Looping. Once again, it is another session of virtual meetup, as it were, because obviously for the last 9 months or so, getting together properly has been a bit of a problem. We've been doing these slightly more frequently than we have when we've had to do the physical get-togethers, because it's a little bit easier to get people together virtually, but I do look forward to the opportunity to get everybody together physically again at some point in the future. I guess given the news we've had over the last couple of weeks, it's likely to be in the summer. This is the agenda for this morning, so a little bit of an introductory process. I give us half an hour for everybody to go around and introduce themselves. If you don't feel comfortable doing so, then that's fine, but it's always a good place to get going. Then we will run through CGM do's and don'ts. We will run through settings and how you what those look like, how those work, what kind of impact those have on the way the algorithms work. We'll then run through Mealtimes, a bit about exercise, site failures and variations, and what I've put in as system-specific discussions. What I really mean is that's an open forum. People can ask questions about how they do things with their specific use cases. We'll come to the end around about 1 o'clock, 1:30-ish. But we can always keep the conversation going or pull it together a little bit earlier, dependent upon how we're getting on. The key thing about today is that there aren't really any rules. There are no silly questions. If you don't understand something or you want to find something out that hasn't been talked about, ask about it. Interrupt whenever you want to. It's really important that the day is about people talking about what I've put together the slides as a guide for, really, rather than as a way of actually, this is what you need to learn. Ask any questions. If things don't tie in with your experience, make sure you raise your hand and say something. The key thing here is that it's about people joining in and sharing their experiences and figuring out how they can tweak things, understand things, do what they need to do. Obviously, this is normally done in a hall, so we would say get up and lubricate as you feel necessary, have drinks at the back so you can go and get them. Clearly, we can't do that now, so if you want to get up and go and get yourself a cup of coffee or a cup of tea, a glass of wine, depends upon where you are, a beer, depends on the time of day, entirely up to you. A case of go with the flow, drop in and out as you feel that you want to do, and the timings that we gave at the start are indicative, so if there's anything there that you would like us to move up a bit, please, and you've got to leave early, please let me know. Most important thing here is that you enjoy yourself, and the chatting always helps with that. The content in these slides comes from various We Are Not Waiting sources, so it comes from some of the Loop Tips stuff, some of that stuff's in Loop and Learn as well. It's from Dana's docs, Katie's docs, and it's from some of the stuff that Achim has put together. So specific thanks to all the people who have contributed to putting these docs together and making them available for people to use and to read. And one of the key things I would say is that we'll always point you back at the documents if there are things that you need to dig into in more detail. And if you don't understand, obviously you can ask on this session, or you can ask in any of the various Facebook groups that are available to people to look at. So we start with CGM do's and don'ts in this session, and that's kind of important because it's always an interesting question as to what should you and shouldn't you be doing. Now, I'm just trying to find the polls on Zoom because there's a little poll I've got that I need to, here we go. So the first poll that we've got up is, what APS system are you using or planning to use before we go into the CGMs? So here we go. I've included the commercial offerings in there as well, just in case there are people who are using them on the session. And it's quite interesting that we're overwhelmingly seeing Android APS use on this. It's not really a surprise given that the target audience for the group was Loop UK and Android APS users, so that's perhaps not such a big surprise, but it's good to understand what our breakdown looks like. Thank you, everybody. And then, I don't know if you've seen the results, but let me just make sure that you've got them all. There you go. So 85% of us are using Android APS. So thank you for that. The second question is, what CGM system are you using? And this is where I realized that when I put it in, I mistyped the name Libre. So Linra 1 and Linra 2 are in fact Libre. So if you could let us know which CGM system you're using.
You're lumping all the Dexcoms together.
I'm lumping all the Dexcoms together, yes.
And can I ask something?
Yeah.
Also, the POCTEC is not here.
Ah, fair enough. I forgot to add POCTEC in.
Yeah.
It's one we don't have available in the UK, so I just forgot about it, really.
Okay, no problem.
It's quite interesting there that amongst this population, Dexcom is about 55% and Libre 1 is 40%, but we don't have anybody using Libre 2.
I think give it time on that one. Wait for the prescriptions to filter through.
I know, but in the UK, it's not yet really widely available. But on the continent, it is a little bit more broadly available. So those are the results there. 55% of the people are using Dexcoms of one form or another. Certainly in Europe, that's mostly Dexcom G6 because they've stopped or almost completely stopped issuing Dexcom G5s.
If you were to ask the question tomorrow, Tim, you'd have had one on Libre 2.
Fair enough. Okay, thank you, everybody. We will.
Tim, what are you using?
I use Dexcom G6 because the Southeast London jumping through hoops to get onto something like a Libre is painful, and because I don't really think the Libre 1 is good enough to loop with in my experience of using it with me. We'll talk about that in this session.
What about Android APS?
I'm using Android APS at the moment, yes. I have been, for a long time I've used Open APS. What I tend to do is make code changes in Open APS and then test it all out in that before I then make the same code changes in Android APS and use it on the phone. So that's my configuration at the moment, and it's really been the 2.8 version that I found operates at a level that I'm comfortable using Android APS compared with having used Open APS previously.
Thank you.
So CGM, the most critical part of the system, as we all know, and we know that bad data equals bad results. Now, as we've got 40% of people who are participating in this using Libre 1, what we're going to talk about here is actually quite important. For those using Dexcom G6, it's perhaps a lot less important because the calibration process with that is kind of, certainly I find it to work very well indeed, and I don't need to calibrate the sensor data. However, I understand that some people do. And what's bad data caused by? So there are lots of reasons why we might get bad data. People want to shout them out or put them into the chat system.
A hot day.
That's one of the more unusual ones I've found, but okay.
Dehydration.
Having a shower. Having a hot shower, I should say.
Light.
Sorry, light, did somebody say?
No, lying on it.
Oh, lying on it. Light is true if you're using Eversense, but yes.
Cold water.
First few days of use where it's settling down.
A duff sensor.
Yeah, that's a big problem. So I'd gone into the kind of what might be reasons for getting bad data, but all of those things that you've described generate what can probably be described as sensor noise in some shape or form. I had some interesting experiences with the Dexcom G6 in a hot yoga studio, jumping dramatically out of line with its readings, which was quite disturbing. I found Libre 2 actually did the same thing, but not quite as badly. So that the heat, hot day, high temperatures, hot showers definitely can have an impact in that respect. Also talk about sensor noise, and sensor noise isn't just those things. Lying on it, i.e. compression lows, is a sensor noise generating event. But also the age of the sensor. As sensors get older, they tend to do this kind of jumping around that I'm waving the mouse around, where the data just jumps up and down a lot and doesn't give clear, smooth lines. And that's obviously an issue if you're using an APS system, especially if you're using one which is doing some form of super microbolus, where it sees a sudden jump and potentially it then SMBs. Now, built into Android APS, and I don't know if the same thing is built into Loop and into OpenAPS, the code doesn't allow it to give an SMB if you get greater noise data than a certain threshold, or if the increases in glucose levels are greater than a certain threshold. So it does do some work to alleviate that risk. It's also why in using the Libre, because of the way the data can be a bit variable, there are concerns about leaving SMB on all the time. Now, we've also got on this list bad calibration, and that's quite important if you're using Libre 1. There's a whole bunch of documentation around in the Libre channels to talk about how it's best to calibrate Libre data, what you need to do to get good comparisons with the blood tests. The key thing with Libre is if you over or under calibrate it, you can run into issues with drift and with quite significant difference from what the real values are. So you do have to be careful of that. And I raise this point at this stage because we do know of hospitalization in the UK caused by bad calibration of Libre 1 using a Meow Meow and using X-Strip. That was the cause of the FDA releasing a warning to users that use of DIY systems may not be the safest thing in the world. And we know where it was in the UK, we don't know who it was, but it's something that we do have to be very aware of. I know, having spoken to consultants associated with it, that they were very close to raising an issue with the MHRA about it. So we do have to be aware that there are potential issues in using DIY systems to convert a non-CGM system to a CGM system. If you don't calibrate it safely, you can put yourself in a very dangerous position, and it has happened. So just want to make that very clear at this stage. I've talked about drift, and that's where when you've done your calibration, the sensor data moves away from where the glucose levels are operating at. And if you have too long a period between sensor calibration, obviously that drift can be wider. In some cases where the sensor link hits the muscle as it goes in, it can cause the data to not be as accurate or as close to glucose readings as you might want. Somebody mentioned around the sensor start. Yeah, that's a pretty good time. I found with the Dexcom G6 that it works pretty well around the sensor start. When I tested the Libre 2 early in 2020, my first 36 hours with it, it just sat at the low level for the 36 hours and didn't give any good data. So there's potentially something that you can see not working properly there. Heat, we've talked about already, and then paracetamol, and that's really only now the Dexcom G5 and the Medtronic and Light sensors, if you're using those, because the Libre 2, Dexcom G6, and I think the Guardian sensors from Medtronic now are paracetamol proofed. They've put a new layer on the sensors to make sure that you don't need to worry about that. So those are the points that I want to talk about around CGM, and just to be clear about it. Now,
just one thing, Tim.
yeah.
When Medtronic introduced the Guardian 3 to Australia, they said that there was a warning about using paracetamol.
Was there? Okay. So maybe
Yes.
they haven't fixed. I thought they had. So, okay. Guardian 3, still no paracetamol. Still way behind all the other providers.
Well, some people say it works fine for them, but Medtronic, when I asked them explicitly, said, no, we warn you not to use it. So
okay.
Nothing conclusive at this point.
Yeah, just mentioning inaccurate CGMs and the mini-link and Enlight is very poor. Yeah, the mini-link transmitter algorithm is rubbish, and the sensors aren't the greatest, the old Enlight sensors. So there is an issue there. And if you can get onto Dexcom or Libre 2, potentially that might help you. So what are good CGM habits? Feel free to stick stuff in the chat or to shout out.
Change sensor if it's jumpy.
Yeah, being aware of your sensor state is an important one.
Careful of where you position it and know how you like to sleep. That is an important one.
Yes, that is an important one.
Don't calibrate too much.
Yep.
Or
Even if you're not
don't calibrate when the levels are rising or falling.
Yeah.
Even if you're not calibrating, still do finger pricks once a day just to check it's in the ballpark.
Yep, that's a very good point.
For me, I'm using Dexcom G6.
Yeah.
And I never make calibration. I trust the machine or the instrument, and the good things, it's calibrated immediately with the loop without my interfere.
Well, that's fair enough. What I would say is that people who have run G6 and actually done tests against blood have found that sometimes you do get variation that perhaps you weren't expecting, but in general, the G6 for most people is pretty good. But it is
accurate,
worth,
yes.
Yeah, I think it is worth checking just to see how it works for you. For example, I've found when I've run some of the tests recently that some of the sensors have been reading between 5 and 10% higher than the blood levels are coming out at. So it's not necessarily perfect. But as we were talking about, regular calibration, whether that's actual calibration or virtual calibration, as Philippa said, virtual calibration, if you're not actually entering the values, is still worthwhile to make sure that the readings are within the ballpark that you are comfortable that they're operating in, as we were talking there with the Dexcom G6. An actual calibration, as somebody else mentioned, when blood glucose levels are as stable as they can be, preferably stable for roughly an hour beforehand and for expected to be half an hour afterwards, and not generally too high or too low. If glucose levels are climbing or falling quite rapidly, or if you're using the Libre, that can throw it quite significantly. The other one is wear for sensible periods. Now, if you're part of the Night Scout or CGM in the cloud groups, you'll often see people talking about wearing sensors for 40 days, 50 plus days. If you're going to do that, make sure you're paying close attention to the sensor noise we talked about earlier, and also the accuracy of what you're getting and any calibration that you're doing, because once you start extending the sensors, the quality of the data that can come out can be a problem. And we're also seeing now, of course, with the Libre 1, that it's possible to extend your Libre 1 sensor using some of the droplet functionality. And again, comes with the same warning that we talked about historically for extending Dexcom sensors. When you extend the sensor, be aware of what's happening. Make sure you are checking that make sure that you are calibrating, because even if that's just a virtual calibration, once you get beyond the specified end of life of a sensor, you want to make sure that the data is aligned with what you were expecting it to be, rather than being all over the place. You really don't want to be that person who puts yourself in hospital because you haven't been paying attention to it. Most people aren't, but it can happen.
What are you terming a virtual calibration?
So that's where you're doing a blood test and it's aligned. So if you're using something that's supposed to be non-calibration, like a Dexcom G6, you're doing a blood test and just making sure that what the blood test does is in line with what your CGM data is.
So we're checking it. We're not actually putting a calibration in.
That's right. It's
one of the
go on.
One of the other nasty things that some people do is they get the reading from the Dexcom app or from the Libre reader, and they use that for the calibration because they don't have to prick their finger again.
Yeah.
And that is a recipe for disaster.
Yes, a self-fulfilling loop of a different kind. Yeah, don't do that. That's a very good point, David. So those are the key points around using the CGMs.
Tim, just to ask a question there about the Libre, the Flash. So calibration, so you just take a finger stick test and then would you wait 5 minutes to use the Libre?
No.
Compare? No.
No. There's no need to do that, because if you're using Xtrip, it handles the calibration for you and puts it in accordingly.
Okay. Thanks.
Yeah, it puts it in the future, so to speak.
Yeah.
But the other thing that's probably worth mentioning is use a trustworthy meter, because you mentioned the readings from G6 being 10% higher. 10% is within the allowed error rate of most meters. You want a meter as accurate as possible.
It is, and to be fair, on that note, I think my preferred meter is the Contour Next, which, when the Diabetes Technology Society did their comparison of meters, is the one that has always come out on top as the most accurate. So when I'm talking about testing, I'm testing against that particular meter because it's had a lot of work done to prove its level of accuracy. There are only about 5 meters that they have demonstrated actually fall within the supposed user guidelines, so manufacturer guidelines of levels of accuracy that are acceptable, and that's one of them. So I would always recommend using that if you can. There is a list on the Diabetes Technology Society's website of
yes. In fact, that list of meters was done so long ago. That was a plain Contour Next. The meter you're using now is the Contour Next 1, which the manufacturer says has even higher accuracy.
Yes, that's
according
right.
to their claims. So yes, there's a list out there, but your meter may not be on it.
So that would mean the finger stick tester would have to be no more than 12 months old, or is that the
no?
It doesn't matter. Is there
not 12
lifespan
months.
on them?
Actually, the list still has a bunch of the AccuCheck ones that are still available, and the Contour Next. Ultimately, it's the technology in the strips as much as it is the meter that is important, and the Contour Next strips and the AccuCheck, I think it's Aviva, I can't remember precisely, but the strips that are used with that, it's their ability to convert the glucose in the blood to an electrical signal efficiently and accurately that's the key piece for the meters, and then the interpretation comes sort of slightly second to that, but the meters on that list give you an indication that actually you can still get most of them, and that strip technology hasn't moved on that fast.
Okay.
But one of the reasons that Dexcom moved to and Libre 1 were introduced with no calibration was because one of the biggest drivers of inaccurate CGM data was bad calibration. It's worth bearing that in mind. Having said that, this was my testing of Libre 1 early in its life. The algorithm has been improved quite dramatically. And across 2 different sensors run at the same time using Abbott's algorithm, that was the difference in the readings in the top graph. And then in the bottom there, you've got Libre 1 with Meow Meow run with different quantities of calibrations over the first 7 days and then the second 7 days. And you can see what we knew already, that over the first 2 days, the data wasn't always great on the Libre 1, but also on the more calibration I was doing, didn't actually seem to make a huge amount of difference to the accuracy of the data as you progress through. It's worth noting that at sensor day 8, we'd done a reset and completely reset all the calibrations, so that over the next 7 days, it was done with fewer calibrations, and you can see what that looked like for me. I mean, the number of readings in this per day was something in the order of 10 to 12 finger pricks, so my fingers were a bit sore afterwards, and it is an n=1 experiment. It just to give some sort of illustration of the effect of calibration and lifespan of a sensor and what the variation looks like over that time.
Tim, can I just ask a quick question?
Yeah.
It's just regarding, obviously, the Libre. It's got a delay of about, what is it, 10 to 15 minutes for the true read?
It's not. So this is the interesting thing about the Libre. There's a myth out in the marketplace that there's a 10 to 15 minute delay on the Libre. All of the published data suggests it's between about 4 and 6 minutes. So the 10 to 15 minute delay, I believe, historically comes from old Medtronic and light sensors, or even the ones with these, what's it called, soft sensors that they used to have prior to even Enlight.
Got a message. Sorry? You've got a message.
That's where those come from. Those were really old sensors, were 10 to 15 minutes behind, even with the Dexcom.
You didn't chat to your dad this morning?
No, Rachel sent me a message saying Jim was nice.
Just a second.
Ah.
Even with the Dexcom G5, you weren't 10 to 15 minutes behind. So there's a story in the marketplace amongst users that it's about Libre's 10 to 15 minutes behind, but none of the data supports that. And to be honest, the technology in Libre 1 to Libre 2 isn't really any different. Libre 2 technology is essentially what's being used in the Libre 3 as well. That's a CGM that's being used with, or likely to be used with, a number of commercial systems. So there's no way it's 10 to 15 minutes behind on that reading. So take that statement with a pinch of salt. It's really about the same as the G6 is. So
yeah, but really reps will say it's 5 minutes.
Yeah,
Libre 1.
It's 4 to 6 minutes, and that's what the data suggests that in the testing that has been done.
Right, that's great. Thanks. I was just wondering if that was taken into account when Android APS does all its magic, but obviously it's not an issue then. That's fine.
No, it's not 10 to 15 minutes, no. So that's it for the CGM discussion. Is there anything anybody else wants to raise on this?
You're a G6 user.
Yes.
I still haven't quite worked out from this conversation. I'm on a Libre. Can you calibrate Dexcom sensors, or is the idea that you don't?
So the G6 can be calibrated, but the idea is that you don't.
Right. And if you observe a measurable difference, you can calibrate it.
Yes.
Yeah. Right.
If you're using G5, that's a once-a-day calibration model.
Right.
Do you have any comments regarding using extra smoothing on X-Strip with Libre to try and get rid of some of the noise?
So I've never used Libre with an APS system. Extra smoothing is an interesting one, right? Because I don't understand how you can use smoothing without it being retrospective. So if Milos is still on, I'd be happy to hear his views on that.
Yeah, took me a second to turn everything on again.
No worries.
So the question is what?
Extra smoothing in Xstrip for Libre 1 for getting the data, using the data in Android APS.
Well, I don't have personal experience with it because we are using Dexcom as well. Well, and I believe that Dexcom is still the safest way to use any APS system. So, but like I said, I don't have personal experience with smoothing data.
If you look at what smoothing is doing, if you look at the way Dexcom uses smoothing in their data on their app, Dexcom smoothing is always retrospective. So you get a blood glucose data point, and then smoothing has to be retrospective because you can't smooth something you don't know about yet. So I'm not 100% clear on how the extra smoothing works within Xstrip. If anybody on the call is and can talk about the use of that, fair enough. I always took the discussions around turning on extra smoothing with a pinch of salt because I felt that it was really about the important thing about using the Libre with Meow Meow is that you don't really want your glucose levels jumping around all over the place, and that's not really about smoothing. That's about hoping that the system you're using with it is going to manage it better. But I would leave that as an open point and maybe something we can come back to or find out a bit more about if anybody wants to do that.
Well, I think the smoothing is always on data in the past.
Yeah, so, exactly.
Yeah, well, it's just about the algorithm. Well, it's the same like with the delay you talk about, because in the principle, the delay is always there.
Yeah.
There's a difference between blood sugar and the skin, the measurement you do in skin. So all this technology is about improving the algorithm, but some delay is always there.
Yeah.
For example, G6 is doing it really well. Just the algorithm predicts the CGM data in the future based on the data in the past, let's say 10-15 minutes. And I have to say that Dexcom G6 is doing it really well.
Yep, I completely agree with you. Completely agree with you. So I'm sorry that's not much help on the extra smoothing, but I don't think that really actually makes any difference when you're using Android APS personally. I'm happy for somebody to tell me different, but that's my view.
Yeah, the bit I found with it is that it helps avoid alarms going off at night with compression lows because it just takes off those little peaks. And the bit I'm wary of is if I'm doing something that has actually got rapid changes of glucose levels, it just delays the system reaction.
Yeah, right. That's fair enough. Yeah, I'm sorry we couldn't be much more help on that.
That's okay.
Okay, so that's the end of the CGM section. The next piece about settings is quite a long one, so if I suggest that we take a 10-minute break to refill cups of coffee or our tea or whatever it is that we're drinking at this point in time, and I will see you all back here at 10 to 11. Dehydration is an interesting point, actually. In CGM terms, dehydration isn't a real thing. It's something that gets talked about all the time in a lot of the CGM groups. But the reality is that your body doesn't work like that. So whilst people like to think that if you drink a couple of glasses of water, it will make your CGM work properly again, and this mainly stems back from the Dexcom days where you'd get the missing data sensor error or whatever it was called in the Dexcom app or on the receiver. Drinking water doesn't get to the interstitial fluid in the time it takes for the Dexcom to recover its readings. So dehydration is not actually a real thing in relation to CGM, in relation to CGM readings. what I believe that relates to is this whole term that used to be used about hydrating a sensor, which was about getting it into the interstitial fluid and getting enough liquid coating it and around it so that it was starting to take readings, which is what that whole 1 hour, 2 hour warm up was about, as well as making sure that they're reasonable and I say calibrated, but you know what I mean. So that's, I think, what the discussion around dehydration actually comes from. It's not anything to do with whether or not you are dehydrated, because the level of dehydration you would have to be at for the sensor not to work would be pretty bad, I think it's fair to say.
You've probably got more important things to worry about at that point.
Yeah.
I have heard some parents swear that if they give their kid enough water, it'll bring those things back to life. And my reaction is usually along the lines of, how bloody dehydrated are you letting this kid become that it would be an issue? It's something else, I'm sure.
I know, it's nuts, right? It's kind of like, physiologically, it's just not possible. But anyway, we've covered that one off. It was one of the things that we should always cover, and I completely forgot about, but there we go. So let's move on to the fun topic that is settings. And I always like to start settings talking about duration of insulin action, or insulin duration, or whatever term that you want to use, because it's quite important. Now, all the graphs that I've included in this session are stolen from some of Katie DeSimone's docs that she put together historically, because I thought, if she's done it once, why would I want to repeat trying to generate these things? And I think they do a great job of explaining what we're talking about here. So we all know, I hope, that when you eat carbs, they exert an upward force on your blood glucose levels, causing your blood glucose levels to rise over time, and you end up with something that looks a little bit like this. And it's self-explanatory. We all know that. We've all got type 1 or are living with people with type 1 who we see this happening all the time. But it's just a little reminder of what's going on. And actually, if you think about it, what the algorithm is predicting when you tell it about carbs that you are eating. So that's something else to bear in mind when you're looking at that. And we also know that insulin reduces glucose levels, and it does so in a very, in theory, predictable way. Again, this is another illustrative model of what the algorithm is doing when it knows you have insulin on board and what it expects to see happen. So those two things, I hope, are pretty well understood by the group and are clear. And I do like the comment that someone's made that carbs exert an upward force on my waistline too. They do indeed. So does eating too much low carb food as well. But hey, we all know about that, unfortunately. And the other thing that exerts an upward force on your waistline is lockdown and not getting enough exercise. But there we go.
Excuse me.
Yes.
Is the insulin duration for all the insulin type, or it's for a special one?
We'll come on to that in a little bit.
Okay. Sorry.
So if we put the insulin duration, if we put the carbs together with the insulin, in theory, because we all know this works perfectly, that having a perfectly matched insulin dose with a perfectly matched carb consumption gives you a nice flat line. Put your hand up if that happens to you every time. Yeah, I didn't think we'd see too many of those.
Only when the wind is right.
When we're feeling very lucky. So, having said all that, what is insulin duration and why does it matter? So what we're doing here, and as I said, it's a Katie DeSimone image, so it's written in milligrams per deciliter for those in the UK, divide by 18 to give you your millimole per litre, or roughly 2 will do, because, divide by 18. Yes, if you divide by 18, 20. It will give you the number that you want. If you divide by 20, it's easier and it's pretty much the same. So if you're looking at 30 milligram per deciliter, you're talking about 1.5 millimole per litre. that's the easy way of doing it. So what we're saying here is that 1 unit of insulin at a 30 milligrams per deciliter will bring blood glucoses down over 4 hours. And it will do that by reaching a peak where it's at its maximum effect and then tailing off throughout the rest of the time. So that's what we're saying here. We're saying insulin is taking effect more and more and more. So it's at its peak effect, and then its effect is dropping off. So effectively, the slope of the blood glucose change will be at its highest at the point where we're around this area here. So that was on 4 hours, but if we say it's only 2 hours and it's the same ISF, what does that mean? Well, what it means is that the glucose levels will drop, but in theory, what the algorithm would expect is that glucose levels will drop much faster because that peak and that effect is taking place much earlier. Now, if you're using Android APS, I happen to know that you can't be having it set at 2 hours, so that's not a conversation. If you're using Open APS, I know it can't be set at that level. If you're using Loop, the default is 5 hours, but it's possible for you to change it. If we've got anybody in the chat who's using a DIA insulin duration of less than 5 hours, can you please mention it? Or you can speak up on the Zoom as well. Either works. It would seem that we don't. No response on that, which is a good thing. Pleased to hear that. So it does mean that everybody has a decent insulin duration in their system. And why does this difference matter? Well, what we can see here is what happens if you've got a blood glucose level you've got a 4-hour DIA and the change in slope. Here we've got the 2-hour DIA and the change in slope. But what we don't show in that, and this is where I start drawing pictures and you all go, oh, that's terrible, is what that means for an algorithm that's delivering insulin. So I'll switch over to a pen and we will hopefully be able to see what I'm talking about right now. So if we've told the system that we've got a DIA that is essentially short, what we're effectively saying is that the insulin action is going to, whoops, and this is where he realizes he's got something the wrong way around. Yep, give me a second. What we're effectively saying is we're expecting the insulin action to last, I'm sorry, it's not the right shape curve, like that. So if that's a short insulin action, so let's say that that's 2 hours, compared to a long insulin action, which would basically be running.
What color are you drawing that in? White?
It's in a black color. Can you not see this?
Nope.
Ah, never mind.
I can, interestingly.
Oh, that's interesting.
Me too. I see it.
Yeah,
I see it. Okay. Oh, it's just appeared.
Oh, okay.
Yeah.
Slow recovery.
It's got to get to Australia.
Yeah, it takes a bit of time, I'm afraid, David. So let's call that our 2-hour DIA, and I've now lost my cursor, which makes it a bit more difficult. Now, what happens if we have a longer DIA? Well, we're expecting it to last, let's say it takes something like that to drop off. So let's call that 4 hours using the numbers we've been talking about previously. Why does that matter? Well, that matters because if you are using an algorithm and it thinks that you've got less insulin on board, but at the same time you're eating glucose, which is having this effect on your glucose, on your blood glucose levels, might be a bit over exaggerated for fun. There's a key point where it thinks it's run out of insulin and your glucose levels are still climbing. So we're going to change color again. The joys of Zoom. So if we come over here, we can see that during this period here, where, I don't know if you can see the cursor movement, where glucose levels are still climbing, under the 4-hour model, there's this much insulin on board. Under the 2-hour model, there's this much insulin on board. So at this point, we can see that glucose levels are still climbing, but there's insulin, a bit of insulin on board here, but basically no insulin on board here. So what does the loop or the AAPS algorithm do when it doesn't have insulin on board and it can see glucose levels still climbing? Well, it gives more insulin again, which means that you start to stack insulin in this period of time here if you've got it set at a very low level, which is why we set our DIA at a higher level, because all the clinical studies show that the duration of insulin action in everybody, including children, is at least 5 hours. And if you have it set to too low a level, what will happen is the algorithm will start to deliver more insulin and you will end up with hypos towards the end of your DIA period that you weren't expecting to happen. Now, the minimum setting in Android APS Loop and Open APS is 5 hours, similar to Tandem Control IQ, where it's 5 hours, and CAM APS actually observes what your DIA is. But the key thing about that is that for quite a lot of people, that's still not long enough. And even using FIASP and Liumjev, which in theory are, well, Liumjev in theory is about 5 hours, you may need to extend that longer. And I'm currently using 7 hours on a Liumjev FIASP mix, because otherwise I end up with it overdosing insulin in the tail. And that's really why we set our duration of insulin action to 5 hours or longer, because actually there's quite a long tail on all of these supposedly rapid acting insulins. They're not very fast on and they're even slower off. And that's the key thing about it here. So that's why we set our duration of insulin action to the level that we set it at. So hopefully people understand that.
Excuse me. That's quite interesting. I tried to explain this to a doctor a few days ago. I didn't do it quite as well as you did right now, but he wouldn't believe me that the insulin duration for a closed loop system would be that short. It would be really helpful to have some papers to give away to explain it to the doctors as well, because they just don't believe it.
I'm just going to put a link in the chat because I wrote an article about it a few years ago, which is quite interesting because it references previous papers that have been written, and some of those are by very well-known endocrinologists, which is the key point about that. And I've lost my cursor. So here we go. This is going in the chat. There are links in there to a paper by, I think it's Gary Shiner, or sorry, by Shiner or Walsh, whereas it's actually John Walsh who wrote a paper in 2010 called Confusion Regarding Duration of Insulin Action. So it's quite an interesting thing to read, but that's the data that's available to you. I don't know if there are any more, but I'm sure you could find some via Google search.
Yeah, thank you.
Yeah, the way I find it useful to explain sometimes is the DIA, the duration numbers that people have got used to on old traditional pumps is an approximation that matches those pumps.
Yes.
We are using a different model that matches reality.
Now, one thing I would be very, very careful about here, and this is something that's going to cause problems when you talk about this with people, is the Medtronic models in the 670, 770, and 780, because they use a term they call, I think it's IAT or AIT, insulin action time, and that number in the 780G is 2 hours, or in some cases, you get better results with 1 hour. It bears absolutely no reflection to the physiological testing that's been done in relation to the time it takes insulin to get in and out of the body. But that's going to cause a level of confusion as people start to use the 780G, and then you'll have potentially DSNs and doctors going, why are you using 5, 6, 7 hours? It's 2 hours. That's what Medtronic say. It's like, well, Medtronic's algorithm isn't looking at the same thing. It's a variable that they use. It's not actually the physiological model that we're using, and by the way, that Tandem use in their setup. So that is going to cause a level of confusion for people. Now, I've just put a slide up, which is why a minimum of 5 hours. If you look at the submission document or the patient inserts and some of the submission documents for various insulins, they tell you what the half-life is for the insulin. So reminding everybody of a bit of physics, half-life is the amount of time it takes to for half of the concentration to reduce, for the concentration to reduce by half. For FIASP, Humalog, NovoRapid, Apidra, or maybe not Apidra, Apidra's slightly quicker, but NovoRapid, Humalog, and FIASP, that half-life is 55 minutes, so just under an hour. So if the half-life is 55 minutes, there is no physical way it is possible for that duration of insulin action to be shorter than, as we've said, 5 hours. And actually, if you look at the graph I've got up in front of us here, it's pretty clear that although there's a small percentage at 5 hours, there is still a little bit here. So if you think about it, if you've done a large bolus, so instead of using 1 unit, let's say that's a 10-unit bolus, down at this level at 2 hours, there's roughly 2 units on board. Coming up to 4 hours, there's still a unit on board there. And that has an impact when you're doing things like exercise, etc. So this is why understanding DIA, or the algorithm understanding DIA, is important in how it works. And what about
Tim,
yes?
I don't remember seeing any documentation on like how to detect this, or like what experiment to do to find out whether this is what's causing your problems.
So
like how to isolate it.
So it's very difficult to isolate. Typically, what will happen is that after a period where, so you tend to notice it overnight, or you'll tend to notice it when you exercise a long time after a meal. That tends to be the time that that you'll tend to pick it up, is that you will have no obvious IOB, you potentially will have negative IOB, have no COB, there will be, there should be nothing really going on, and you'll have repeated incidences at different times of day where you end up with glucose levels. Generally, you'll find yourself hypoing. The way I identified it on my setup was that I was seeing hypos for no obvious reason that didn't tie in with an insulin carb ratio or an ISF change or a basal rate quite a long way after insulin had been administered, other than kind of what I was expecting to do. But in order to identify how much beyond 5 hours you need to be, you do tend to need to look through your data and just see what's going on. And a lot of people figure out that actually that 5 hour point is too early for them and they need to move it down. It's not a very easy thing to identify. And generally what will end up happening is that you'll get a bit of instability. And if you push out that DIA by half an hour each time, it will reduce the instability. That tends to be what you see happening.
What I would mention here is that if you are unsure about the right value for you, it's definitely safer to have this value higher than lower.
Yes. Yeah, absolutely. What you're trying to avoid is additional insulin when you've already got insulin on board. So there's also often we've seen questions about, well, I'm a fast absorber. Well, what does fast absorber mean is always an interesting point. If you actually look at half-lives, so if you were a fast absorber, let's say that you had a 45-minute half-life, what does that do to the curve? Well, 45 minutes is around 20% faster than the regular 57 minutes that we said from the documentation. Doesn't make a huge amount of difference, actually. So it's worth bearing in mind that fast absorber, A, isn't backed up in the data that's been determined, but B, doesn't actually make a huge amount of difference to the amount of time it takes to get through the insulin within the body and for it to be used up and removed from the process. So that's just a few things about why we use a longer DIA and what the reasoning behind it is, and how the algorithms, because of the way the algorithms work, why short DIAs are not a good approach. So the next stage of this is moving on to pump settings. So taking the first, I think we just jumped, pump settings. So one of the first things that we will always say about pump settings is, if your basal rates are wrong, everything else probably is too. Now, what do I mean by that? And this is one of the key things about Android APS and the objectives and why you have the objectives there. Historically, when you jumped onto Loop or onto OpenAPS, you don't have any process to go through to figure out whether your levels are right or not. And the recommendation was always to open Loop, follow what the system was recommending, and then determine whether or not actually your settings were correct. The key issues are that if your basal rates are set to too large amounts of insulin, what you tend to have done as a pump user is set them up so that the basal rate actually absorbs some meal carbs, and that results in your ISF and CR values being set incorrectly because your basal rate's actually dealing with meals for you. And the other way we've seen it historically is that basal rates are set too low because somebody's got their ISF or CR values in their pump set very aggressive, i.e. to a smaller number. And what that ends up doing is when you plug those numbers into the algorithm, it all goes horribly wrong, as you can imagine. So getting these right is kind of an important part of what's going on. And as I mentioned at the bottom there, small, large, what? There's always a bit of fun around what we mean when we talk about the numbers. So let's start with basal rates. This is a graph that I've stolen from somebody else, but it doesn't matter too much. This is Anna Di Simone. It looks perfectly all right, doesn't it? It's running between 70 and 120. It's flat. It's an overnight trace. But what if should the limit have been? So is this okay? Is the big question. Well, it could be. On the other hand, it might not be. And why do we ask that? Why do we say that? Well, if the target level was where the orange line is right now, then no, it's not okay, because the number is, something's not working right there overnight, and the glucose levels have ended up being much lower than they should be. And likewise, if this was the level that we were targeting, then equally something is wrong with the overnight basals, because the glucose levels are running far too high. And the key thing here is that we're looking at overnight basals mostly for this, and overnight basals are a really good way of understanding what's going on with your basal rates in general, because it's a time period where you don't have any carbs on board generally, and you can assess an idea of what's going on. And what do I mean? Well, if we look at this particular version of the graph, we can see that, and by the way, the target here overnight is the blue line, which is 120. And we can see that using loop here, the glucose level is nowhere near 120. It's sitting well below. And that's a problem because that's not what the user wants. And we can see the insulin's being turned on and off, and quite frequently it seems to be giving a bit more than basal, but then again it's been dropping out. But the key thing here is that the IOB in the overnight period has resulted in waking up with an IOB that's 1.3 units lower than the expected IOB would be using basals alone. And that's a key indicator that there's something not quite right with what's going on here. And what can we do with this information? Well, what we can do is we can figure out that we probably need to make our basal rates overnight lower. And that shows because we're carrying that negative IOB, the glucose level is below or just below target, and the overnight basals have been going on and off throughout the night to try and figure something out. That last point is perhaps less obvious as we move into algorithms which use SMB type functionality. But if you're using loop, you potentially, and less so over F1, you potentially will be seeing that on and off model. The key thing is that you've got negative IOB and your glucose levels aren't actually running around the target level that you want them to be at. The other thing to take away from your overnight basal being too low is that it's likely that something similar is going on throughout the day. And the alternative to this would have been that the glucose level was running at, let's say, 150 when the target was 120. And the system was trying to give more insulin, and the IOB number was a positive number, would indicate that your basal rates overnight were set too low. So what you'd want to be doing is considering increasing those basal rates. So this is just sort of some of the indicative data that you have relating to the system that helps you to look back and go, okay, maybe there is something there.
Just one question. How many days would you look at this data before doing any change on your system? Because if it's every day, then it's logic you change. But if it's 1 or 2 days,
so I would always say 3 days.
3 days, okay.
I would always say 3 days. I don't think it's a pattern until it's happened at least 3 times repeatedly. Other people can jump in with what their points of view are on that, but I've always said it needs to be 3 times the same thing happens effectively on a daily basis for you to be able to make the call that it's actually a pattern.
I agree with him. You should definitely use more days before you change something. But I would put here my experience when you have a child, especially small child, then the sensitivity and everything is changing really fast. And in our case, situation like this indicates that the necessity of insulin or the insulin amount we need is much lower. And if this happens during night, it will continue during the day as well. So in this situation, when you have a child, I would definitely start some lower profile, like 80%, 90%, something like this.
So there's a question, how much IOB should be showing on wakening as an indication of basal being okay? So what your IOB indicator is a net IOB. So is it how much more or how much less than you would be predicted with your standard basal rates. I would suggest if you're between 0.0 and 0.3 above or below, it's probably not too much of an issue. If you're greater than 0.3, then you might want to start considering making some tweaks. I think that's probably a reasonable rule of thumb. But obviously it's up to you to make the decision on that.
Yeah, I would also concur with the 3 days or so. I must say that my wife was getting pretty upset by the 3rd day at the overnight alarms before I decided there was a pattern.
Yeah, well, if you've got overnight alarms that are annoying people, yes, that's a slightly different situation, yes.
Can I ask, Tim, is that 3 consecutive days or like 3 days within 7?
I would suggest you'd want 3 consecutive days, because if you're, one of the challenges with this is that most of the way systems work, they don't pattern identify always that clearly. So if, for example, you found that on a Friday night and a Saturday night, you always had the same kind of thing over a few weeks, then potentially it's actually Friday night and Saturday night you need to make a change. But if you saw that on Monday, Tuesday, and Thursday every week, you saw something happening, then potentially what you actually need are different profiles from Monday, Tuesday, and Thursday compared to a Wednesday, Friday, Saturday, and Sunday. So there's a level of pattern identification which is kind of manual in that, to try and understand what's going on. And that's one of the main reasons that having night scan data can be really useful, because you can go away, you can look at the pictures of the previous week, 2 weeks, and just see if there's anything in that that helps you identify longer term patterns that might help you.
Thank you.
Well, this is perfectly chosen example. I would return a step back when Tim was talking about the duration of insulin action. And he told to you all, if you remember, that if you experience IOB under 0 for a longer time, for a longer period during the night, that may indicate that the duration of insulin action is too short. So please, Tim or David, do not answer, you know it, but for others, do you think this is the right example or not? So the problem here is the base rate or duration of insulin action.
I would want to do some traditional basal rate testing, switch the loop off and check that my basals are correct first, I think, before I looked at DIA.
Yes, definitely you should do the basal testing, but if you have exactly this example, it's the problem of basal or it's the problem of duration of insulin action, and why?
The line is pretty flat, so not so sure it's basal or ISF. Could be, but I would also look at the duration of insulin, because normally if basals are not correct, you have more changing in the insulin lines. I saw on mine examples.
No, I don't think there's been no bolusing in that example there in the recent past. So I would call that a basal issue rather than a duration of insulin action, unless this person's had something to eat at midnight and bolused for it.
Yes, exactly. That's the point. In this case, it's the basal because there was no positive insulin in the past.
There is one function in Android APS which I find useful in this, which is the graph of the blue IOB graph, where you can look back over time and see what the IOB has been overnight, yep. Not just what it is right now.
Yeah, you have that. You also have that in Loop. You can visually see the IOB based on your settings and figure out whether what's happened is, well, figure some out of what's happened. As somebody made a comment in the chat whilst we were going through this about changing one thing at a time, because that is kind of important. You don't want to be trying to change everything at once as you are trying to figure out what's going wrong. So that was kind of the key thing about trying to figure out basals and some of the tricks you can use to help identify whether your basals may or may not be off, using overnight as an example. So here's another example, and what's going on here. So we can see this is another early morning into the daytime with a run through the day here, or the morning here. Clearly there's some food being eaten here. But what do you think this particular graph tells us about the basal rate in that early morning period? Feel free to anybody to jump in and to tell us what you think.
Looks too low to me because there appear to be a lot of SMBs going on there. So the algorithm's thinking there's not enough insulin on board to keep the level at target.
So what are you saying about the basal rate at the point in time we're talking? So where this line
low.
is.
Oh, where that line is.
So what we're looking at is from that line back over these 3 hours or so.
Yeah, I would say it's too low.
It looks like the loop's trying to reduce the amount of background insulin, so I'd say it's too high, isn't it?
So what are the key things to look at in this graph?
IOB at that point is negative.
So that's a good point to pick up. What's another good point to pick up just looking at that graph?
Looking at all those, they look like SMBs, the little boluses.
They are SMBs, yeah.
Yeah.
So what I will do is we'll just talk through this a little bit because it's kind of helpful. What we've got on here, show me my pens again. Let's go for a pen. There are a few things we can actually see on this which are worth highlighting. So first of all, we can see, I lost my pen again. That would have been helpful, but there we go. Right, we're back. So what we can see here is there's some SMBs taking place in the early morning that are there for a reason. What is the reason that those SMBs are there? Well, these SMBs here, and it's not letting me draw on the thing, so we'll never mind, are there because what we're seeing is that there is a rise taking place, and there's a temporary target in place just here. This temporary target indicates that the target glucose level during that time period is actually generally higher, so it would normally be somewhere up here. So that would normally be where we'd expect our target to be, given that we can see that just here there's a temporary target, and just here there's a temporary target, and those are both for eating soon. So given that, we can also see that the basal rates here are being held back a bit, and we can see that there are SMBs taking place here. So that's roughly 7 a.m. So we'd expect the DIA on those to run out to around about 12. We also mentioned that the IOB here is negative. So the question is this a basal rate issue or is it a DIA issue? Now, this is actually an example from me, so I have the advantage of knowing that my DIA is actually pretty well aligned, and that during this period where there wasn't any food and the glucose levels remained below the target and didn't ever come back up to target, in spite of the loop trying to drop the basal insulins here to try and help it come back up to target, suggests that the basal rate's probably set a little bit too high, and maybe the insulin sensitivity is also not quite right during this time period. But that's kind of just trying to show what we've got in this data set to try and help us to identify what we're looking at and whether we can do something with it to make our lives a little bit easier. Is that clear for everybody? I'll take the no responses as okay. So then we also have the fun piece of insulin sensitivity factors and carb ratios and how we talk about them. Now, I put this in because it's always something that causes no end of confusion, even now in the world of DIY, and often actually when you're talking to healthcare professionals as well. So the question is, what do we mean when we use a terminology? So here's a poll for you all to complete. And that's a good representation of why we have to be very careful of why we use the right terminology when we're talking about what these numbers mean. If you look at the results of that, we can see that 21% of respondees think that ISF is too weak means the number is too small. 72% means they think that the number is too high, and 8% aren't really sure what we're talking about here. For me, ISF is too weak would mean that the number is set to too high a number, whereas too strong would mean is set to too small a number. What I would suggest is that when we're discussing this stuff and when we're talking about it in Facebook groups, rather than using the terms too weak, too aggressive, too passive, too strong, we actually are very specific about talking about it and say the ISF number is too large, or the ISF number is too small, or the carb ratio number is too high, is too large, or the carb ratio number is too small, just so that people can clearly understand what it is we mean and what we're talking about. Because the use of the terms aggressive, passive, strong, and weak do cause challenges in understanding what's going on and how you help people when they're struggling to use one of these systems or find their settings are out. So just using an example here from, this is actually from Loop Tips. You may have seen it already, but if you haven't, that's fine. What we're looking at is a roller coaster glucose level. We've got insulin leading. If you're using SMBs, it may look like there's boluses occurring here in these zones. But what does this tell us, and what should we do?
I have this problem.
Okay.
It looks. I think my ISF is. Let me get the terminology right. I think my number is too low because of it. Because the loop is giving me insulin to try and stop a rise, and then it's going lower than target. So the loop thinks, stop, and pulls the basal off completely. Then it starts to rise, and then it gives too much insulin, and it goes down too far, and then the loop kicks off again. So. And
I would say that's exactly what you want to do, and I've deliberately used a term there to make it confusing. Yes, I would agree with you. I think your ISF number, and I think in this case, we know that the ISF number was set to too small a number and needs to be increased.
And this leads me on to the DIA thing, because I also think that my DIA is too short. I've been using 5 hours. Because that was the default, and I made the assumption that the people that put Android APS together know more than I do. I think I just went with the default, and also the literature that comes with FIASP says 5 hours as well, approximately. So I'm assuming that can have an impact on this, can't it? Because
it can, but what you tend to find with because the time frame over which this is occurring is relatively short, and your DIA tends not to have the same effect over quite such a short period. But yes, it can confuse what you're looking at, which is why to spot DIA issues, it's generally easier to see when, for example, you've had a lunch bolus and then something happens. So say you've eaten lunch at 12, and you've had a bolus with lunch, and then at 5:30, the loop starts delivering insulin and you're going low for no obvious reason because it should be working at that point in time. That's when you tend to, excuse me, that's when you tend to spot DIA issues. But it is a challenge. It's not the most straightforward thing in the world. This type of pattern is typically more a case of the ISF number being set to too small a number.
The frequency of this, the distance between those wave crests, is fairly constant when this problem occurs. It's usually an hour or a little bit more than an hour. But that may be different with the Umjev and the faster insulins. So there can be some variation there, I guess.
Yeah, it can. I mean, this is a Humalog graph. I found, we'll talk about faster insulins at the end, but there's some other interesting points around that. So Tony just mentioned he sees tea time dips. Yeah, it's worth looking at your DIA, Tony, in that scenario.
Yeah, I do too.
And Theo, yes, the whole point of the answer being make ISF weaker is deliberate.
Okay.
Trying to make the point that that's really not a very clear answer as to what does the user need to do in this context, and that is to make the number associated with ISF a larger number.
Okay.
So moving on, what about carb ratios? So we've got two examples here. Neither of them is an SMB example, but you can see similar things happening with that. What we can see is sawtooth glucose levels, even with temp targets in place. And we can see a food bolus. Actually, no, does have SMBs in, sorry. So this SMB has sawtooth, and this meal bolus has resulted in a low that's had to be treated. What are we talking about here? What's the problem here?
Carb ratio number is too low, logically.
Oops, sorry. Yeah, make the carb ratio less aggressive. Again, deliberately making the point difficult to understand. The carb ratio in this case is probably too low, and it probably needs to be more like 1 unit to, let's say, 10 or 12 grams in the second graph than 1 unit to 9 grams or 8 grams as it looks like it is. And these are just some of the patterns that you can start to see in this case. But it's not always obvious. That's the key thing here. Sometimes these things aren't as obvious, and we've tried to pick more obvious examples here where we know what the cause is and what's going on.
Presumably, you need to be quite confident that you're carb counting accurately before you do anything about that.
Yes, but you can test it, right? So you can do an accurate carb count test to find out whether it's right. And this is the point that we started off with at the start of the session, and which we're about to go on to now, which is how do you fix all of this? And ultimately, if it's not working for you, stop, go back to basics, and try and figure out, are your basals right? If your basals aren't right, then it's pretty sure that your ISF and your CR won't be right, so you need to do something to modify those. So whilst all these are identifying symptoms, fixing them goes back to the fundamentals of using a pump, really, which is try and make sure your basals are set up correctly, and then adjust your ISF and CR using the types of tests that are widely available on the internet to help you identify those things.
Just one question. How do you define for you, or in general, if it's not working? Because normally, I'm not sure about it, but the loop working with 90% timing range between this 4 and 10 millimole could be great, but could also be bad.
So you have to make that decision for yourself, right? Is the loop working for you? Well, if your time in range is 40% using the loop, then probably not. If your time in range is 75%, but you're seeing stuff that's higher than you want it to, are you comfortable with that, or do you want to make changes? It's really a very personal decision. Excuse me. If it's not causing you to struggle with hypos, if it's not causing you to have periods where you're uncomfortably high, then ultimately you have to make that call. I'm never going to sit down and tell you that the loop isn't working for you. If you're achieving a time in range that's 75%, you're getting the same levels as the commercial systems are getting. If you're getting 80%, you're getting better than the commercial systems are getting. The key question for you is, are you happy with what you have? And if you aren't happy with what you have, and it's causing you either anxiety or it's causing you issues related to things moving up and down a lot, then this is what you would need to do to go away and have a look at it. But it's not really a case of is it or isn't it working in a very clearly defined set of questions. It's ultimately about whether you as a user are getting out of the system what you want to. And if you are, then you are perfectly able to carry on using it as you do. If you want to do something different, if you've decided that you want to get a higher time in range, for example, lower time in below 3.9, lower time above 10, that's really your call to make.
Thanks.
And Carol's mentioned it should be stable and without any alarms. That's if that's what you want as an individual. As David mentioned, the overnight alarms was a key issue for him that meant that he needed to make some changes because his wife didn't like the overnight alarms. It's really about what are the things that annoy you or annoy those around you that cause using the system or cause your management of diabetes to become a problem, rather than about if there's anything objectively wrong. So with that in mind, let's move on to mealtimes, everybody's favorite subject at 11:43 on a Saturday afternoon. So Saturday morning in London, perhaps less so in other parts of the world. Mealtimes can be, when you're not using various technologies, a problem. And so what I've done here is I've stolen a picture from Dana that's kind of quite a useful one to look at. It's quite a typical pattern that people see with meals, as somebody's mentioned in the chat, in fact. Often what people will do using the faster acting insulins, this is a graph from a Humalog user, for example, is you'll pre-bolus before a meal in order to be able to make sure that you time your insulin to the glucose rise. You'll get the timing wrong, and then potentially you'll go low or be heading low 60 to 90 minutes after a meal. You'll feed the low, and then you'll rebound all over the place, and you get this rather unpleasant sine curve in your glucose levels caused by things not working quite how you thought they would. If you're using one of the newer faster acting insulins, you're probably not pre-bolusing, because for many people that's not a requirement, as those who mentioned that they're doing no meal announcement, no bolus strategies with Android APS at the moment. And this is why mealtimes, even with a loop, are not the easiest thing to do. And the key thing to remember is a loop isn't magic, because insulin historically, less so with Lyumjev, is slow. So you're trying to match insulin use with the food that you're dealing with, bearing in mind that historic insulins tend to peak at 75 minutes rather than the 15 to 20 that everybody was told when they were given them 20 years ago. So one of the most useful techniques is eating soon. And this is a really good way of trying to manage postprandial rises. And why does it do that? Well, essentially, this is a technique that can be done with a loop, but it can also be done without a loop. And we've been talking to various clinicians in the UK, and we bring up this eating soon principle, and they kind of, this light bulb goes on, and they start to talk about how they can use this with some of their more able MDI users. And essentially what we're doing with eating soon is that we're taking insulin before the meal, an hour up to 90 minutes before the meal, but generally about an hour, that is aimed to bring the glucose level down to a slightly lower target than you would normally be operating to, so that you have insulin on board before you eat. And then when you do the meal bolus around the meal, it means that you've already got insulin on board, and therefore you're taking additional insulin to help you through after the meal. Now, I don't know how many people on here are using Eating Soon. I forgot to put a poll together for it.
Yeah, I'm using it with automation.
Because it's a very good way of reducing post-meal highs. That's one of the key things to be aware of with it. The way I personally use it is I set Eating Soon zones in the morning and at lunchtime, and then I do the same thing at weekends around certain time periods, where the algorithm is able to set a lower target and start to do stuff. And it then means that the other thing with Android APS and with OREF1 is that Eating Soon also effectively triggers UAM to work more effectively. And what you're then doing is that if you have those insulin boluses and you're working with a no bolus approach to a no bolus, no announcing approach with Liumjev, it allows the UAM to work. And it's a very, very powerful technique. How powerful? Well, I was able to test what happens when you can't automate Eating Soon by going on to, by using CAM APS. And it was very interesting because I had to go back to pre-bolusing, even with a Liumjev Fiasp mix. Sorry, no, a Fiasp, it wasn't Liumjev at the time. Even with Fiasp, I had to go back to pre-bolusing by quite some way because I couldn't automate an Eating Soon process. What was quite interesting with CAM APS at that point was that it started to recognize that I was doing that pre-bolus and started to learn about it and do an Eating Soon effect prior to my meal times. And it took a little bit of a time for me not to have to pre-bolus and for it to then be able to manage my Eating Soon period for me. But I was suffering from quite high postprandial glucose levels as a result of not having that Eating Soon function operating. And it is quite a big thing actually in terms of managing meals. So Tony said, trouble is I don't tend to eat at a set time, always varies around a time-ish, but never dead on. No, that's not really important because the point that you're doing, the thing you're trying to do is to get more insulin on board to get you to a lower temporary target. You're not trying to put in place the insulin for the meal. And by having the insulin for the lower temporary target, if you do use the bolus calculator, when you then enter the details of the meal, it knows about the IOB and can delete that from the amount that you require for a meal bolus.
I think the trouble is that traditionally, certainly in pre-pump, pre-pump clinics, it was always drilled into me from DSNs that it was always a really bad idea to be taking insulin before meals. Obviously, this is old school, but it's still difficult to break that psychological. I'm going to have a load of insulin now, and maybe I'm going to eat in half an hour or an hour. Save something.
But the thing is, right? Take a step back from this, Mark, and let's have a look at the next slide, because I think that. Oh, I won't bother with the next slide. We'll just talk about it on here. You're not giving a load of insulin is the first thing that's important. Loop does have an Eating Soon option. There's an Eating Soon or meal temporary target button. I can't remember the name of it on Loop, but you definitely have that in there. And what you're actually trying to do here is you're actually only giving a relatively small amount of insulin. So let's say you were running at target, so your target was 6 and you were running at 6. What eating soon is then doing is you're saying, right, eating soon's enabled, I'm going to eat in the next 90 minutes. So, and it's going to be towards the end of that 90 minutes. So my target's now 4.0, so it's gone from 6 to 4 in that time. What you're then enabling the algorithm to do is to deliver insulin to try and get you to 4. And it's bearing in mind whilst it's doing that it's going to look at your ISF number and look at the constraints that it has and know that it can turn insulin off and on. So what it's then going to do is going to, if you're using loop without auto bolus, increase your TBR to get you to that 4 target. That's not going to be a huge amount of insulin. So let's assume your ISF is 2 millimole per liter at that point. In order to get you to that 2 target, it's looking at that 2 target over duration of insulin action. Sorry, that 4 target over duration of insulin action. So it's expecting that if it gives you insulin now, you will get to 4 millimole per liter in 5 hours. So that's what it's giving you the insulin to do. So the 2 things going on are that you're getting a small amount of insulin and you're getting it with a prediction that's going to run out over quite a long time period, so that when you come to your meal, you've actually got the insulin on board, and then you do a meal bolus without that insulin to top up, if you like, so that you reduce the postprandial high.
Okay, fine. Sorry, when I said a huge amount of insulin, it was it was a term that maybe not actual words used, but it was a gesture that was always don't have insulin aboard until you've eaten. I'm looking at loop, and at the bottom it looks to be an icon that's grayed out, which probably now is insulin on board, but it's so it is the eating soon, but that's kind of grayed out, so I need to obviously read the docs.
I'm not sure why that would be. Yes,
grayed out.
And you can use this with all of the systems. Within Loop and Android APS, there are buttons within the GUI. If you're using Open APS, you can set Eating Soon as a temporary target in Night Scout, and it does exactly the same thing. And if you want to automate Eating Soon in Night Scout and you're using Open APS, you can do that with an IFTTT button, or an IFTTT automation that will set Eating Soon according to an entry in your calendar or according to a clock timing. So those are some of the ways you can set Eating Soon with the different systems.
You mentioned giving less insulin at the meal based on the Eating Soon having provided insulin. You mean that the calculator would do that, or do you need to calculate something?
The bolus calculator will look at IOB. So if you've already got IOB, then it's going to remove that from the meal bolus. As long as in AAPS, you've got the IOB consideration ticked. Comment about not in 2.8.1, Norman, what's that?
Hasn't the download from Night Scout been disabled in 2.8.1?
Yes. So, but for Android APS, you've got automations, and you can automate and then run it and run it from the GUI. So the Night Scout use is more important for Open APS users rather than Android APS users at this point in time. So that's Eating Soon, and I find it makes a big difference to what happens to my postprandial glucose levels. Others have mentioned in the chat that they do find it helpful.
Of course, not every day is simple. 2 days a week, I have breakfast and then immediately get on my bike for an hour's commute to work. So there's a big balancing act to do there.
Absolutely, yes. You're completely right. It's never as straightforward as it will always work like this. So, for example, I have eating soons when I've been working in the office that operate at breakfast time because I have breakfast in the office and cycle in beforehand. But yes, it's about your activity, your calendar, and how you do things. So, at the start of the session, we talked about how people were using their systems, and we had some mention that they were talking about they were using Android APS with Lyumjev in a no bolus, no carb announcement fashion. There are multiple ways of doing this. Certainly with Mealtimes, most people, from what I understand, especially if you're using Humalog and Nova Rapid and the Pudra, don't really have a choice but to use something like Eating Soon with a mealtime bolus. With the faster insulins, you can actually announce a meal and not bolus, and in some cases you'll find that it actually works quite nicely, and you never have to do the bolusing yourself. The reality is you need to be using OpenAPS or Android APS with SMB and Loop with a high enough max TBR and the auto bolus branch to get anything out of this that works well. But I kind of use a hybrid of this or dosing insulin and not telling it about meals, even with Lyumjev, because Lyumjev doesn't actually work as fast for me as it does seem to for other people. So I unfortunately, I'm not able to use it a fully closed loop in this scenario. So that is an option for people if they're comfortable using it. You do really need the autobolus or SMB functionality in Android APS, Loop, and OpenAPS for this to work. And then, of course, we have what's been going on in Android APS with Lyumjev. This is Mathieu Teller, who has configured Android APS, and he's doing no meal announcement, no manual bolusing, fully closed loop, and this is what his 24-hour graph looks like doing this, which is really quite nice, and it's a fantastic experience being able to run fully closed loop. Those people on the call who are doing that right now can testify to how fantastic it is to not have to actually think about diabetes at all and let it get on with it. I've mentioned at the bottom here, Android APS with SMB and UAM may require some code tweaks. You certainly require automation around profile switching in order for it to work effectively. At least that's what's been told to me. And you do need to make sure your profiles are tuned correctly when you're doing that. Does anybody who is using a fully closed loop with Lyumjev want to add anything at this stage in the conversation?
Yeah, it doesn't work so well if you drinking beer an evening long with chips. So then you will rest on the 10 line and it won't go down until you stop drinking.
That's the kind of feedback I like.
But for the rest, it's pretty fine.
That's pretty cold.
I experienced the same as you did, Tim, if I got it right. For me, it doesn't work without bolusing, pre-bolusing. I use about 2/3 of the amount of insulin I would normally take for the food, but I don't announce carbs anymore.
Right.
Works fine for me so far, and I am too lazy to tweak my settings to go to full because I don't have time at present. I don't take the time for that.
That's fair enough. I mean, I kind of I either enter carbs or I do boluses. I don't tend to do all of it at the same time. And what I found with Lyumjev is, even with Lyumjev, there are some food types that you it's just not fast enough for. And I also find that after a period of time using it, I have to revert back to a mix to sort of calm it down a bit, because my glucose levels start to really not be very predictable using it. But very different people have had very different responses to this. So in some cases it works really well, as we've seen. In other cases it's not quite as perfect. Can't help that, but it's one of those things, unfortunately.
I've got a couple of questions. So we don't have Mealtimes in our country yet. The fastest thing we've got is Fias. I've been using that for a year now, and I've now got things to the stage that I have not bolused since November. Now, a lot of the time I'm relying on unannounced meal mode, but for especially higher GI foods, I will give it a heads up and do carb announcements.
Yeah.
Why would we, I can see on this particular graph, we have lots of profile switches going on.
So why? Because for some people, just using the standard algorithm doesn't work.
Simple answer.
Simple as. So there are, these are the changes that Matthew has had to make this work for him. So he's automated various profile switches to maintain the levels he wants and the performance that he requires. This is where it becomes a person by person kind of scenario. It's what we have noticed about the faster insulins is that individually people seem to react very differently, and as a result, what you need to do to make things work for you is potentially more complex, and there's not necessarily a pattern across users that is immediately obvious.
Yeah, when I started using Fiasp, I used it for a long time as a mix, and then eventually I went to 100%, and I have a suspicion that that may have got my body used to it before it had to deal with full strength, whatever. My profile is fairly tuned. I am adjusting my profile every month or so. I've just gone through that again today, but I'm not having to do profile switches.
Yeah, great.
There was a time when I played with profile switches, but they always felt like a hack and often too aggressive, and I couldn't quite find the right point. So I'm interested to see how it goes, and I'm hoping to get Mealtimes one day.
Yeah, I mean, I can't answer of that, David. I think it really is individual dependent. I mean, for me, I just cannot use Mealtimes really well without as a no announcement, no bolus model. High GI foods, I'm shooting up to far too high levels if I do that.
Yeah, when I started on Fiasp, I thought, oh great, I'll try the no bolus thing, and I went out for Mexican, and that was a mistake. It works better when you've tuned everything very carefully.
Yeah.
Sorry.
Go on.
Yeah, that's right. You have to. It's a bit tricky to figure it out. You have to adjust ISF and start some automation temp targets or things like that. It's really can be tricky. I used it with Fiasp and with Mealtimes, and for me the difference between both insulins is not that big, so it works with both of them, more or less. So but you're right, Mexican food and Chinese food is really tricky, and you have to help the system to cope with it.
Chinese, I have to bolus quite a bit early on before it'll, if I want to not end up going up to a level of around 180 to 200, and then it's staying there. That's the only way I can do Chinese food.
Yeah, yes, but I think this no bolus thing is really amazing. How APS can deal with it. I'm impressed. I'm really impressed.
Now it's worth mentioning here at this point that Android APS and Open APS are the systems that can do this. I wouldn't recommend it with Loop because Loop doesn't have the functionality to do that. The key functionality that allows the no meal announcement is the unannounced meals, which when it detects a certain level of rise with various factors, allows the algorithm to decide that actually there are carbs on board in some shape or form and then act in a more aggressive fashion. Loop doesn't have anything like that, and therefore it can't do the same thing. And that means that with Loop, you just can't get away with doing that. The best way of illustrating that was a study that was presented at ATTD that I always mention now, which basically gave loop to a bunch of pigs and gave Android APS to the same bunch of pigs, having tuned their settings very carefully, and then allowed them to eat food as they would normally. The test with loop gave them a time in range of 40%. The test with Android APS gave them a time in range of 65%. If you consider that that time in range for the pigs using Android APS fully closed loop was better than most people get using MDI in the UK, that's quite an interesting statistic. But that's the difference between the two systems. So just something to think about. Now, there was a mention earlier about e-carbs and dealing with them and how the platform works in relation to all of these things. So effectively longer acting carbs, low GI foods, what happens with protein and fat, all of these things. And actually, just a comment that Achim's made about Lyumjev with it getting, with your glucose level getting stuck in the 180s. And yep, I completely agree with that statement, Achim. I've had exactly the same experience where it goes up and gets stuck. So, yep, I know what you mean, and it's entirely frustrating when it happens. So anyway, back to the longer acting carbs, protein-based stuff, fats, how that all works. There are a number of ways of doing this, but what the intention of doing this is to tell the algorithm that there are carbs on board so that it reacts with insulin in a way that it wouldn't do without carbs on board. Now, as we were talking about a couple of minutes ago, because the OREF1 algorithm has this UAM concept, it's less important for the OpenAPS and Android APS users, but it does give you something you can do as a loop user. But before you use e-carbs with Android APS, I would always suggest trying to use the algorithm on its own. What we see quite frequently is people coming in to use these platforms and then going, right, well, I used to use a temporary basal rate for dealing with my pizza. How do I do a temporary basal rate using Android APS, using Loop, using any of the other, using OpenAPS? And the answer is, let it have a go on its own first so you can figure out what you need to change. Now, I've mentioned Robert Silver's FPU tool. That's a really useful way of distributing carbs over a long period of time. But if we go to how you can enter this stuff, there are different ways of doing it. You can either use a longer absorption in Loop. So if you're putting in something like a pizza, you might put 5 or 6 hours absorption into it. You can use e-carbs in Android APS, as I've just mentioned, where you would put in the carb amount, the duration of that e-carbs, and then the time at which to start identifying those. So we've got 2 hours duration, 60 minutes in the future. Or you can include protein up front in your carb content and just let the algorithm deal with it. Now, I tend to do that and tell it if I've got something that's a relatively high protein meal, 50% of the grams of protein added to the carb number, and just let Android APS or OpenAPS get on with it. Oops, sorry. But the key thing is that actually the algorithm itself is actually pretty good. The OREF1 algorithm itself is pretty good at dealing with these types of things, as we've discussed with the no bolus, no carb entry with the faster insulins. So actually putting this kind of thing in may not be what you need to do. It may be that there are other settings that aren't necessarily quite right that you might need to consider. But it's always best, I find, to put the carbs in up front with the protein added to it as well, so that it gives the algorithm a chance to play it through. Does anybody want to comment on any of this stuff? Because I know there were questions about how to deal with sort of this type of thing at meal times.
You mentioned earlier that you were taking sort of 60% of the bolus insulin and letting APS work out the rest, or if I understood correctly. How do you set that one up? Because in the bolus calculator, you just enter the full amount of carb that you're taking, and there isn't sort of an instruction to say apply 60% or whatever percent you want to.
So you don't do it as a percentage, but if you're in Android APS and you go into the somebody else needs to just let me admit somebody in. You go into Android APS and into the carb calculator, and then you put in your carbs. You can then adjust your insulin dose. So there's a line that has CORR.
Yeah.
So if you look at it, so if you put 50 in now, you'll have a result. If you then hit the negative button on CORR, it reduces the amount of insulin that it will give you at that point in time.
That's okay. It's just a calculation you do yourself rather than it setting a rule up in the.
That's right. Yeah. I mean, okay. what I generally do, as I mentioned, is I bolus and then leave a UAM to deal with the carbs, because that works for me. But if you do need to enter them, that's how you would adjust the insulin in the in Android APS's bolus calculator.
Okay, thanks.
Tim, I've just put a screenshot in there. I was just wondering, with regards to, I've always been a bit confused. When you come to use the bolus wizard, you know, you've got the carbs on board, the bolus insulin on board, and the basal on board. Obviously, depending on which ones you tick and untick, it depends how much insulin it gives you.
Yeah.
I've just gone literally on, I normally leave the carbs on board ticked, but if that doesn't feel right, because you get a feel for things, don't you? I might change it to another one, but it'll change the amount of insulin it gives you.
Yeah. I mean, one of the things that, if you look at what each of these things is doing, so I don't use the 15-minute trend because I don't use the bolus calculator, let's be honest. I just basically dose some. I've been using the ORF1 algorithm since it appeared in 2017. And for me, the great thing about it has always been that you can just bolus some and then leave it to deal with stuff in the background, or enter carbs and leave it to deal with stuff in the background. And I found that to be tremendously helpful. I don't know whether people want to try doing stuff like that, but it's certainly something that the way the algorithm works is actually quite useful to do. If you tick the BG level, what it's effectively going to do is try and reduce. It's going to add a correction to bring you down to your target glucose level when you're using the bolus calculator. If you click the COB, it's going to take into account any carbs on board that remain in the platform, which, if you think about it, if you've already bolused for them fully, you don't necessarily want to be ticking. So it's something to be aware of, because it's going to increase the amount of insulin it gives you. The 15-minute trend is basically looking at whether you're dropping or rising. So it's suggesting that if you're dropping over the last 15 minutes, then it will take your ISF number and reduce the amount of insulin it's giving you by the drop that it's seen. Whether that's useful is up to you to decide, but I again don't use the bolus calculator. But those are just things that it's dealing with, and COB is an important one to be aware of, because you would normally expect the system to have already bolused for those carbs, and by ticking that box you may be over bolusing. It depends on how you're using it.
Okay, thanks very much. Cheers.
So before we move on to exercise, does anybody have anything else they want to raise?
Hi, Tim. Can I just ask, we're on objective 10 at the moment, and we've just tried starting to use SMBs. And I've read the docs and I've searched the groups and asked lots of questions, and we're just really struggling. One of the things that's been suggested to us is to use the bolus calculator, to enter all of the carbs up front for the meal, but then use the minus button to only bolus for, say, half of the carbs.
Yeah.
But finding is that then.
Sorry, we lost you at the end there, Donna.
Then we don't even know he's kicking in, even when the levels are rising and rising. Don't know what we're doing wrong, and don't really know what we can try, because and that they just don't work. They don't seem to kick in.
So Donna, we missed the
quickly
bit.
Enough at
we
all.
We missed the bit after. So you're saying that, if I can summarize it, you are entering the carbs in the bolus calculator. You're reducing the insulin dose at the initial point. You're delivering the bolus
into the bolus calculator. Yeah.
Yeah. Then you're delivering the bolus.
Sorry, I've got a really rubbish internet connection.
Yeah. So you're delivering the bolus. So you've got insulin on board with the carb on board data, and what you're finding is that the insulin effectively isn't acting effectively, and you are going high. Is that what's happening?
Yes, yeah. So SMBs won't even kick in, and
right. So the reason SMBs would kick in is because the predicted glucose levels are getting outside of the outside of your target. So that's why it won't give you SMBs simply because you've put carbs in and because the insulin dose has been reduced. It will only give you SMBs if it believes you're not going to come back to target.
Mm-hmm.
So you might want to check the carb ratio. You might also, are you using Eating Soon?
Yeah.
And
yes,
so
yeah.
it may be that you've got insulin on board plus the insulin you've given. That means that you're not getting any additional insulin. The key thing to look at is it increasing basal rates?
Yeah, that's what I mean. It can go up to 500% basal, and then only afterwards it might use SMBs, but sometimes it doesn't do that, even when her level's quite high.
So what are her basal rates like? Are they very small numbers?
Sorry, you cut out there. Our internet connection's rubbish.
Are your basal rates very small numbers?
I think the maximum is 0.48 or something.
Right. So that will be the reason for you not getting SMBs, because you've got very low numbers on your basal rates. The default setting for an SMB is 30 minutes of basal, maximum of 30 minutes of basal. There are other constraints on SMBs as well. And what it will be doing is it will be calculating that because of her low basal rates, probably quite a large number for carb ratio, that she doesn't need that much insulin that can be given as an SMB. That's usually the reason in those circumstances why you're not getting SMBs. And it can be quite challenging to deal with. What I have seen in the past people looking at is using diluted insulin for something like that.
Mm-hmm.
So it's that's the issue with it.
Okay.
It's not. I don't think it's anything you're doing wrong. I think it's the low levels of basal rates are resulting in SMB requirements that can't be delivered by the pump.
Yeah, I mean, we've noticed that it will deliver in increments of 0.2 and 0.
Sorry, you cut out there, Donna.
Sorry. We've noticed it will deliver in increments of 0.2 and 0.1. It will do SMBs of those doses.
Yeah, and that will be what it's probably requiring a smaller dose than that, and therefore, which pump are you using?
It's the combo.
Yeah, so that's probably the reason for it, is the smallest dose it can give. It can't give with a combo.
We're just really struggling. We need the equivalent of what we were doing before, some extended bolus, instead of having to manually give chunks of insulin at a time, because she's just getting so many roller coasters.
Yeah, I have to admit, I don't think there's a great answer for that.
Yeah.
The only way it will be able to deliver insulin is as TBRs, which I'm assuming it will be doing, and you'll be seeing TBRs coming off and on.
Yeah.
And that's going to be fundamentally a limitation of the way.
Okay. No, that anyway.
Yeah. Okay. Sorry that I can't be more helpful
Thank you.
than that. Okay. So, anything else on Mealtimes? Okay, let's move on to the exercise section. So, I hope most people are aware that the effects of exercise on your glucose levels can be very variable. Aerobic exercise tends to result in glucose levels dropping. Anaerobic exercise tends to result in glucose levels rising. And then mixed exercise can be a bit of a free-for-all, and good luck to you trying to work out what's going on. One of the things you're trying to do when you're using an APS system is help it with some of this stuff. And it's not always easy. If you're using Loop and Android APS, the facilities you have to help you with this stuff are profile switches and temporary targets. If you're using Open APS, you have something called exercise mode and temporary targets. And by using exercise mode with a higher temporary target, it has a schedule over those different targets as to how much it can reduce your maximum basal insulin by, which all helps with how these things work. The key things to consider around exercise and APS systems, and the same is true whether you're using a commercial system or whether you're using a DIY system, is that you're trying to reduce the amount of insulin on board during and after exercise, where the exercise is likely to cause a low glucose level during the exercise or a low glucose level after exercise. So the type of exercise that you are doing does become important in this. Now, why is that? Well, as we mentioned on the previous slide, if you're doing an aerobic type of exercise, the likelihood is you're going to go low during the exercise and stay low after the exercise. If you're doing something that's anaerobic, something like a HIIT class, or weights, what tends to happen is during the exercise, your glucose levels rise and may continue rising after the exercise before dropping back, and you becoming more sensitive post the exercise. And what you need to do, therefore, is figure out how you need to manage that. And that's what we're going to try and talk about a bit here. So what do you do for minimizing IOB during the exercise? Well, there are two approaches you can take. We mentioned the setting a temporary target. So if you set a temporary target at least an hour, I personally, if I'm going to do aerobic exercise, set it for 2 hours beforehand if I can. Set a higher temporary target, because that means the algorithm gives you less insulin on board because it's trying to bring you up to that target. We talk about activity target being at least 3 millimole per liter higher than your normal target, or 54 milligrams per deciliter, because that gives enough room for it to reduce, for the algorithm to reduce the amount of insulin it's giving and get a significant change in IOB. You can also take into account, if you're using AAPS or Loop, the override and profile switch functions, whereby you would go to a reduced percentage of insulin, and also you would also set your ISF to be a larger number to suggest that you're more insulin sensitive, so that when it gives insulin, it gives less insulin when it's trying to correct something that it predicts is going to be high. And you also need to be very careful about your pre-meal boluses, because obviously if you're carrying IOB from a meal, it's very hard to get rid of it by setting a lower percentage profile or by a higher temp target. So those are all the things that you can deal with pre-doing exercise. My personal experience is, as I mentioned, for aerobic exercise, an hour, 90 minutes, set a higher temp target before doing it, I need. If I'm doing anaerobic exercise, what I find is I don't need anything during the exercise period, but when I'm come to the end of the exercise period, or I'm about 15 minutes prior to the end of it, I need a higher temp target, because what happens post-prandially is post-exercise is my muscles are trying to reabsorb carbohydrate to restack the glycogen, and I become much more insulin sensitive post that period. I also find that I need to run after weight training specifically, or after a longer run, a 24-hour long higher temp target, because I am more insulin sensitive. And that's kind of a key thing that people often forget in relation to exercise. And even then, that doesn't necessarily work. This here is a graph from me doing, I play cricket in the summer. People don't think cricket's a particularly active sport, but if you're a fast bowler, which is what I pretend to be, it's quite an anaerobic type of exercise. And overnight, even though there's a high temp target set here at around 8.5, when my regular target is 5.5, and there wasn't really any major meal going on earlier, I've still dropped as a result of insulin given, and even with 0 basal rate overnight, doesn't want to come up, and it's only as we get towards the morning that it starts to recover, but it still stays very, very low compared to the temporary targets that I've got in place. So when you're doing exercise, it's not just the pre-exercise and during exercise pieces that you need to check on, it's also your post-exercise levels and making sure you're doing the right things to deal with that. Before we move on, does anybody want to raise anything in relation to exercise?
Tim, when you talk about your temp target an hour or 2 hours before you're doing aerobic exercise, is that before you've had a meal, or would that be post a meal?
That would be during the whole period. So if I'm having a meal during that time, it would still be within that. Right.
So if I'm exercising before I eat, i.e. first thing in the morning, would you still expect a temp target to be necessary?
It depends on what exercise you're doing. I would still be setting if I'm going for a run in the morning, I still have an automated temp target that operates from before I wake up, so that I don't become too insulin sensitive.
Okay.
So I still find I need it. You may not, but I do.
Yeah, because you haven't mentioned about eating before you exercise in terms of extra carbs.
So you generally want to try and avoid it if you can, because if you think about it, the challenge with all of the APS algorithms, whether they're DIY or whether they're commercial, is that once the system knows about carbs on board, it's going to try and deal with them. So if you have breakfast, let's say you do a half bolus for breakfast, you set a high temporary target, you may set a profile switch with a decreased percentage profile, it still knows you've got those carbs on board and it still tries to deal with them. So not only are you doing the exercise that makes you more sensitive, you've also got the algorithm trying to give you more insulin to deal with the carbs it knows about. So you may not want to announce those carbs. I notice that David's mute is off, so I'm going to go to him because I know he has to deal with this stuff as well.
Yeah, I run a higher temp target starting at least an hour before the exercise, and a large part of that for me is reducing the IOB. If I put food into the system, the system is going, when it knows about the carbs, it's going to bring the IOB back up. And when I start exercising, the muscles would seem to preferentially use the insulin that's there, and then the carbs get to look at it later. And I'll end up dropping. So I want to reduce the IOB. I try not to eat before I go out. If I'm stuck and I'm going for a ride and it's sudden, I haven't had that hour to get things set up, I'll probably have some extra food to buffer me through in the knowledge that otherwise, with the IOB that I have on board, that normally would be fine, my muscles will take the glucose straight down. So I run that temp target from at least an hour beforehand, and I cancel the temp target when I finish the exercise. For some exercise, I'll run a profile switch to change my sensitivity, but that I will leave running for later. So that's what Tim was talking about. Sometimes it'll be, I'll run a different profile target all night, the profile switch, but I won't run a different temp target overnight. I'll just have a different profile switch saying my sensitivity is different. So
presumably
there's a bit of experimentation going on.
Presumably that extra carbs you would have, you don't announce that to the loop.
It's generally better not to, but you do have to be aware that because Android APS has the UAM in it, if it does see that, if it does pick up those carbs, and it may not when you're doing exercise because you're more sensitive to insulin and therefore you're actually just using them to fuel existing IOB, if it does pick up UAM, it may try and deal with them.
I did try different variants, and the first thing I have to look at is, like David said, is the IOB. I can't start doing exercise with IOB that is high.
Too positive, yes.
Yeah, zero, it's okay, but okay-ish.
Yeah. So this is one of the things I found particularly hard about trying to use commercial systems, is that they give you no information about IOB. And if you're exercising and you're used to exercising and looking at your IOB to make that call, it becomes really difficult to actually do anything when obviously you can't see that information. And that's quite an interesting piece of feedback to commercial options, is that if you don't know what your IOB is, or if it can be a challenge. So before we move on, does anybody have anything else they want to raise in relation to exercise? I will take that as a no, and we will move on. So slight failures in managing variation. So what we're doing here is we're just trying to pull everything that relates to things that might go wrong into it. Things like hypo, things like persistent highs, site failures being a source of persistent highs, all this type of thing. And this is something you often see quite a lot of questions about in the Facebook group. But site failures, what about site failures if you don't know insulin on board? So I suppose the question is, how would you know insulin on board? And you can potentially make a guess at what's been delivered. Certainly if there's an occlusion showing, it's more likely there's less insulin on board. But the reality is, if you've got no idea about how much insulin is on board, the loop thinks you will have a certain amount. You might not agree with it, and the loop will act in a way that is based on the insulin that it has delivered. So if you are concerned about what's there, and you think you're going to need more insulin than is already done, than it's already been delivered, it might make sense to suspend the loop and go manual for duration of insulin action to try and figure out what's going on. Now, bear in mind, if you leave the loop running, if you're higher than it thinks you are, it's going to try and give you more insulin, but it's not going to give you more insulin than it thinks is safe. So it would be a challenge. It could end up being a challenge running with the loop. If you think you've got a reasonable estimate of the insulin on board, you could put a new site in and then prime the difference, but don't prime the entire difference, because if you've got one of those situations where you're not entirely clear what the insulin that's being delivered is, you don't necessarily want to overdo it and then result in a spanking hypo that could result from that kind of event. So it's about, again, it comes back to individual judgment, and whether you're using a DIY system or whether you're using a commercial system, these are the same problems, and they're all based on estimation and your own judgment, and then observation of glucose readings afterwards to make sure that nothing's going horribly wrong.
Yeah.
And that, unfortunately, is just the sight of living with a pump.
One of the problems I found with occlusions, if someone was to say have a 2-unit bolus an hour ago and then you decided it didn't work, oh, I'll put an extra 2 units in now, everything's been shifted by 2 hours. So if you prime the extra amount to say, oh, it's missing, so I'll give it the extra units, those units are working on a different time scale and everything gets a little bit messy.
Yeah, that's true. So you do have to be careful about what you're doing. And which is why, really, if you think about it, if you're going to prime or inject to fill the gap, that's why you don't want the full IOB stated. You need to think carefully about what you're doing.
What I will do sometimes is with OpenAPS go back through the treatments and find ones that I are reasonably confident didn't work and remove them. And then the system's IOB will go down. But you've got to be careful not to remove too many.
And you do have to be confident that they didn't work.
Yes.
So this is why it becomes about knowing the way the system works with you and what happens to you in relation to this kind of setup. So it's, unfortunately, there isn't a good way of fixing this, and you just have to go with the old-fashioned ways of handling site failures as you would have done with a pump. What if you're stuck on a high glucose level? What things can you do there? And this is where you would be pretty certain that your site isn't the problem. Anybody want to hazard a few guesses?
Go for a run.
Sorry, go for a run.
Depends how high it is, surely.
Yeah, if you're at 18, would you go for a run?
Depends how I'm feeling when I'm 18.
To be fair, I would never go for a run.
Actually, it's an interesting point. I've sometimes found if I've been stuck somewhere where the glucose level is higher than I wanted, and I'm thinking it's just not correcting and coming down, I will get up off the couch or away from my desk and walk around the house once, walk outside, walk back in, and just that exercise seems to get things moving, and suddenly everything comes back into line. You don't necessarily have to go for a big run.
Yeah, and I'd agree with that. I've noticed this during lockdown, where I've actually spent more time sitting at my desk than I have normally in the office, because instead of getting up and walking to meeting rooms and walking to get a coffee, you sit at your desk and talk to people on video conferences all day. And just that getting up and moving causes your muscles to use glycogen, and therefore to need to suck glucose in afterwards in order to replenish just the small amount that you've used, and that seems to get things working, as David says.
I can second that, definitely. Sorry.
No, it's okay. I think if the glucose is very high, 18 or more, you're supposed to take 2 units of insulin. Then after half an hour, you can go for a run or do an exercise. It will help to reduce the high level.
And one thing I would hope is that for most people who are using APS systems is that 18s are a rare occurrence rather than a common occurrence, or because in general, the system's trying to handle what's going on anyway. These are some of the things that you might do if you are stuck on a high glucose level, and obviously it depends on how high you are. So, for example, you might set lower temporary targets. You might profile switch the opposite way as when we were talking about the exercise, so there'd be profile switching or overriding. You could use the bolus calculator and see if it's got any pending insulin that it thinks you should be given, and then you could give that as a bolus. We know people may be stuck on high glucose because they got their carb count wrong at a meal. So you might go back, think about what you had, review the packaging and go, oh, I got that wrong, and correct your meal entry. We know people use fake carbohydrates. That's not ideal if you're using something like auto-tune, because it's not a good way of dealing with it. But people do enter fake carbs in order to try and get the loop to react and bring glucose levels down. If you're going to use fake carbs and they do work, make sure that you are able to deal with a low that may result from that, because obviously there's no carbs on board. I personally have an automation running on Android APS where if my glucose levels get above let me just check the automation, get above 9, I think it is. Yeah, above 9, then it switches to 130% profile, which does seem to work quite effectively. And I run it for a short period of time, so if it remains above that, it can restart and then rerun until the glucose levels have dropped. Ultimately, you may have to open loop and correct manually. And it's also worth checking settings to see whether something like ISF or carb ratios are the reason why your glucose levels have gone up, say, after a meal, and then the insulin you've given hasn't dealt with it, and the insulin the thing has delivered hasn't dealt with it. So there are quite a few things to look at and to consider if you see regular patterns of being stuck on high glucose levels. Achim mentioned earlier that with Mealtimes, and I've seen the same thing, that sometimes you climb after a meal, you then get stuck at a high level and it doesn't do anything, and then all of a sudden you'll plummet and then drop low. I've seen the same behavior, and that's the answer to that one for me was go back and mix Mealtimes with Fiasp, and it took that behavior away. So it might not even be anything to do with anything the loop is doing. It might be something physical or related to the insulin you're using that you might need to figure out. So it's all about looking at patterns, understanding the patterns, and then being able to react to those. And if you're having problems with those, asking for help in the groups to see if anybody can give you some advice. Is there anything that anybody wants to add to that?
Depending on your insulin, I would be tempted to change my pump set and get a new vial out of the fridge.
Yep, that's another thing that may be an issue, yes. That's a very good point. So let's move on to hypos. When you are low or heading low, what do you do to treat it? Now, most of us will give carbs or take carbs. Should you use a higher temp target? Should you use a profile switch or an override? What are your thoughts?
Main point for me is being low. I always have the feeling if I eat carbs, they must react immediately, even though I know they don't. So for me, it is always the risk of eating too much hypocarbs, bringing me up way up again. So that's why when I announce carbs, I announce part of them I ate.
Right. It's an interesting one, right? It's ideally you should tell the loop about the carbs that you're having for a hypo. Do you need to announce them at the time that you've had them, or could you add them afterwards? And what I've found can be useful is to not announce them at the time I've had them, but to do it 15 or 30 minutes later, so that the system's not going to react necessarily. Now, if you're using a higher temp target, and actually if you enter carbs in Android APS at the time of a hypo, it will set a higher temp target at the same time for 45 minutes as default at, I think it's 8.5 millimole per liter. And that's a good thing because it reduces the impact of the algorithm trying to correct for the carbs you've eaten.
I think it's 6.5.
Sorry?
I I think it's 6.5.
Okay, because I have mine set at 8.5 because I don't think 6.5 for a post-hypo temp target is high enough. It doesn't give you enough room, especially as I find, and I know a lot of people find that post-hypo, if you give insulin, you're actually more insulin sensitive, and therefore potentially 6.5 isn't enough of a difference to not suffer from repeat hypos.
8.5 feels very strange for me because it's way outside my normal range.
So to give you an example, if I set 6.5 and I'm coming up out of a 3.5, then within an hour, even with a temp target of 6.5, I'll be back below 3.9. If I set 8.5, I'll peak at around 6.5, but I won't then drop back down to the hypo level. So that's my reasoning for it. Again, this tends to come back to 15 minutes. In the chat, Vicky Iliadou has mentioned that the norm says 15 grams of glucose, then check blood glucose in 15 minutes. Now, of course, you're using an automated insulin delivery system here, so it's already predicted that you're going low. It knows about your insulin on board, and it has expected and anticipated you're going low, so it's set a 0 temp basal rate and not delivered insulin for some time prior to that happening. What this usually means is that the amount of carbs you'll need for a hypo are much lower. And often you'll find that instead of needing 10 grams or 15 grams, you might only need 5. But that's obviously going to be based on IOB. So whilst the traditional method is 15 grams and check glucose after 15 minutes, once you're using an automated insulin delivery system, that tends to not be the right way of dealing with it. And you've got less insulin on board, you give less carbs, and you'll still come out of it generally without too many issues. Obviously, that's not a recommendation for everybody. You have to understand how you react to carbs on board when you're low, but it does give you something that you can consider, and it should help you stop eating the kitchen when you have a low. Obviously, it won't always, but sometimes it will. Tom's mentioned going back into hypo after just coming out of it is one of the biggest grievances he has with AAPS, especially at night. Now that pattern is usually caused by eating carbs, UAM, and not having a higher temp target post your hypo treatment. And that's why you should have a higher temp target post your hypo treatment. Individuals generally have to figure out what is the right hypo temp target for them, as I mentioned earlier, but it is something that you need to figure out, unfortunately. Just having a quick look through the chat to see if there's any questions. Nothing there worth raising. Vicky again mentions if you're older, you just can't feel the stress of the hypo. I think what you're talking about is hypo unawareness, and that's not necessarily an age thing. That is generally more likely to be linked to loss of hypo awareness. And there's a whole load of work that the likes of Pratik Chowdhury has done, Hypo Resolve, and all of those programs to help you recover awareness of hypos. One of the things that you may find, some people have mentioned it, is that in using an automated insulin delivery system, that actually you can recover some hypo symptoms. There's no clinical evidence of it, but it's something that you might see and want to have a think through. Anyway, moving on from treating a low, let's have a quick look at this example. In this example, the user is running in open loop, so let's just be clear about that. The glucose level is 4, which is obviously below their target and below their rate and just at the bottom of their range. And this is a question we see regularly. Android APS is suggesting an increased TBR. This might help you with some of the objectives as well if you haven't got to this stage yet. Why would Android APS be suggesting a higher TBR in open loop if glucose level is below target?
Is it because you've got negative ion insulin on board.
So we have an answer, negative insulin on board potentially. Do we have any other answers?
The blue prediction line is ending up above target.
We've got the blue prediction line ending up above target. Anything else? So the most important thing is that the predicted glucose level is going to be above target. One of the conversations that seems to happen cyclically in the various looping user groups is that, oh, it's got negative IOB, it therefore must be giving me insulin to counter negative IOB and get me back to 0 IOB. That is not what the system does. And I've said this on every time we've run Living It with Looping. Net IOB is not a key driver for giving you more insulin. A key driver for giving you more insulin is the prediction.
It, however, is used by the bolus calculator if you go into that.
And the bolus calculator is not using the algorithm that Android APS uses, which is the other key point in that. The net IOB is a consequence of the decisions the algorithm has made, but the key thing that drives whether the system thinks you need more insulin is the predictions that it is making. And therefore, if somebody says, oh, it's your negative IOB, therefore it must want to give you more insulin, that simply isn't the case. It's the prediction that drives the insulin delivery requirement, not the net IOB being negative. And as David says, and we're just highlighting there, if you're using the bolus calculator does not use the OREF1 algorithm in order to determine how much insulin you are delivering with a meal. So the two things are actually separate. So does anybody want to raise anything on this?
Hi, it's Jess here. So I basically fit locked whenever I hypo, and I'm no fit state to change my predicted glucose until probably about half an hour after. Yeah. Is it still worth doing it then?
Sorry, not change your predicted glucose.
Well, I'm in no fit state to change anything on my pump.
Yes.
Whilst fitting. So is it still worth increasing your glucose target like half an hour after coming out of hypo?
So what I would suggest you do before we even get there, how frequently are you finding that you are going low? Because you did mention earlier on that you were seeing that quite a bit.
Yeah, well, 3 fits this week. Yeah, quite often.
So, where do you run your target at?
5.5 to 6.
So I would initially run your target higher, because if you're being pushed down to hypo quite regularly to the levels that it's causing you to fit at, it would suggest that there's a setting that's out of line somewhere. And the best thing to do to manage that in the meantime is to run at a slightly higher target. And then to review what your settings are and to figure out whether actually maybe, and I'm assuming you're running OpenAPS with auto-tune automated on it?
Yeah.
So the other thing I would do is delete or rename the auto-tune folder, and then create a new auto-tune folder and start auto-tune again from scratch with wherever you're at the moment, because it does sound as though your settings are probably not in quite the right place. And with OpenAPS, the way to protect on that is to run with a slightly higher target for now.
Great, thank you.
So yeah, take that 5.5 to 6 to probably run at 7 to 7.5 for now. And then if you're having problems, absolutely jump on the looped group, ask questions in the Gitter channels, because I think that would be a good thing to do.
Is two questions. Is it worth talking about having a range as the target versus a single level?
We can do that. Yes. I mean, if you people.
Sorry, just to one other thing relating to, I think it was Jess's question was, if you, I guess if you're fitting, you're not eating carbs straight away. Sometimes when we eat the carbs straight away, it's too much hassle to go and declare the carbs. And sometimes we'll declare them later, but I try to declare them backdated so that when the system analyzes stuff, it's got a chance of knowing when they came in.
So, I mean, certainly if you're using auto-tune, it's really important that you do back declare them.
Yeah. But sorry, back to the thing about the range versus the single target.
Yeah. So historically, as users of various systems, we've been encouraged to set ranges within which we want to operate during a day-to-day basis. So historically, a range was the range of glucose levels within which you wanted to be when you were using, for example, the bolus calculator on a pump. So that the pump would then, when you entered your carbs, would give you an insulin amount to get you into that range, and would then give, if you like, give the pump a bit of a space so that you ideally wouldn't go too low. So essentially, if you're using a carb calculator on an insulin pump, sorry, a bolus calculator on an insulin pump, if your range was set to 4 to 7, you were at 9, you were doing a mealtime bolus. What it would then do is give you insulin to correct for that range, and then to give you for the carbs as well, based on the IC ratio. When you're using a DIY APS system, and this is actually only applies to DIY systems because the commercial systems don't have a range. What you're then doing by giving it a range is saying, right, okay, this is the range within which I want to get to, and dependent upon the system you're using, it will correct either to a number in the middle of that range, or it will correct to a number at the top of the range. And likewise, when you're rising, it will, or falling, it will adjust based on a number within that range. Realistically, once you get to the point where you're using an APS system, it's actually better to operate a single number as your target, because it takes away some of the variation in what's going on, so it's easier to understand the actions that are taking place. And ultimately, when you're moving things around, it means that it's easier to make those changes if your range is simply a number of 5 rather than a range of 4.5 to 5.5. So realistically, if you're currently still using a range, that's probably as a hangover from what you used to do with a pump. And the reality is you're better off with a single target number for the algorithm to work to. David, is there anything you want to add to the target range conversation?
No. Historically, the systems, open APS systems would actually target, or Android APS would target the bottom number of the range, which wasn't always what people expected. But the other thing, when someone said, oh yes, I want to target between 3.9 and 10, and then they'd say, I'm sitting at 12 for hours, it's not doing anything, because it was only calculating corrections to get you down to 10. So yes, a single number somewhere in your green visualization range is probably the easiest thing to understand what the system is trying to match against.
Yeah, absolutely. So that's everything that I've got for people today. The next session is kind of an open forum, and people can raise what they want to talk about, and we can go through anything that you have as a concern. So what I'm going to do is I'm going to take the slides off the screen. We'll go back to a video conference view, and it's kind of open floor. If you've got any questions, please feel free to raise them.
Hi, Tim. Can I kick off with a question as to which you would look at first, ISF or carb ratio, if you think you are having problems in one of those areas? Is it better to focus on one over the other?
Well, if you think you've got problems in both of those areas, then you probably want to look at basal rates.
Ah, right, okay.
Because usually you don't have a problem with both carb ratio and the ISF without the basal rates being off somewhere.
Right, okay, thank you.
Tish, you've asked, is it best to update for each new release? If you're using Android APS, well, you've got 60 days to update before it becomes predictive low glucose suspend only, so the answer to that one would be yes.
Hi Tim, Chris Carter. Would like to just ask you a question for my daughter Amy. Amy is using AAPS Combo and G6. Could I ask you in terms of what pump you're using and generally how you're finding it?
I mean, I've used over the last year a Dana RS, Insight, and I'm currently using Medtronic pump because that's actually what my contract was for, and historically I used OpenAPS. Frankly, until the Dana RS had the Inset 2 infusion sets, I hated the Dana RS infusion sets because I was having to change them every 36 to 48 hours because it just didn't work for me. They were uncomfortable. They were leaving massive holes. But I've used the Inset 2 type sites for years with Medtronic pumps, so actually that makes a big difference. The Dana RS is a great pump for using with an automated insulin delivery system because its connectivity is fantastic and it works very well. I've used Medtronic pumps for years. They all work fine for me. I also actually really like the Insight. My problem with the Insight is I got it out of a contract and I run short on the sets. And the shop that I used to buy sets from in Europe no longer distributes to the UK because we're no longer in Europe, in the EU, and therefore I have to limit the amount of use I have on that. But I think if you find a pump that you like that is compatible with Android APS or Loop or OpenAPS, then go ahead and use it.
Tim, just for your info, the Inset 2s now work with the Dana RS. That's what I'm using.
Yeah, they do, and those new Inset 2s are great.
Thanks, Tim, for your thoughts on that one. Appreciate it.
Tim, can I just ask, about the updates to Android APS?
Yeah.
I thought if I was running version 2.6, which is the first one, the only one we've ever installed, that it didn't force you to upgrade. But then the other day we did get a notification banner on the top of the Android APS screen saying the 2.8 is available. So is that also, does that apply to us? Do we only have 60 days from the 2nd of January or something to upgrade?
So it's an interesting question. I think actually 2.6.1.2, getting into the level of detail, is actually okay because of the Android 7 piece, and I don't think that one will go to predictive low glucose. But if you're on 2.7 and up, you will get moved to predictive low glucose suspend.
We're using
maybe 2.6.1.4 actually, but yeah. So that version of 2.6, the last version of 2.6, from what I understand, doesn't force you into predictive low glucose suspend after 60 days of the alternative being available.
Thank you.
And I believe, if I remember correctly, when you're on the 2.7, 2.8, it's when it's a 0.7 or a 0.8 update that you're required to do the upgrade. I don't think the lower levels, so the 0.71, 0.72, or sorry, 0.81, 0.82 forces that upgrade, but I may be wrong on that.
Sorry, Tim, with the 2.6, if I'm on 2.6.1, I don't need to upgrade, or I won't lose functionality if I don't.
You won't lose functionality.
Okay, thanks.
But you should think about doing it at some point anyway.
Yeah, I mean, the key thing is that the move from 2.6 to 2.7 introduced some bug fixes to the code, which is what always happens, and also changes the GUI and a number of other factors on it, and reintroduces some stuff that has been turned off for a long time.
Can you explain GUI? I'm not quite sure what that is.
The user interface.
Thank you.
GUI, graphical user interface.
Yes.
Tim, it's Chris. Could I try another question? I read with great interest your recent 1 month trial with CAM APS.
Yeah.
I was just curious in terms of, did you, I also appreciate that it's not the cheapest solution out there, but
no.
it obviously wasn't you're still using Android APS, so it didn't make you think that you wanted to switch then?
So for me personally, the issue for me with CAM APS was, as much as anything, the Dana RS I was using was a trial, and fortunately I could give it back because the sets were awful, and I just couldn't cope with the way the sets worked on me. I have tuned Android APS and Open APS to make my interaction as minimal as possible, whilst I still need to do some bolusing in relation to meals. It does a pretty good job of me not having to do too much. And with CAM APS, I don't get the same level of reduced interaction because it still requires meal bolusing. It's not quite got the same level of functionality in that for me. I know for some people that they are very happy with CAM APS and have moved off Android APS to CAM APS because it takes out the maintenance cycles that come with using Android APS. It means they never have to build anything, they don't have to check their settings, and frankly that's quite nice, the way that the system just understands you using it and then starts to modify its behavior in accordance to the way you use it. And like I mentioned previously, it started to see me giving pre-boluses for an eating soon type functionality and then started doing it itself. So it learns your behavior and starts to deal with those kind of things rather than you having to set up automations to do it. And that is something that's very clever with it. My understanding of Diaboloop is that is also quite similar in what it does.
Okay, thanks for your thoughts on that, Tim.
Alex has mentioned about free APS. Does anybody use it? I don't think we've got any users here using free APS. I think I've used the auto bolus branch, but it's not quite the same. I know Melissa, who's not on with us today, also uses, Melissa Holloway uses the free APS version. What some of the key things in that are the ability to use the variable carb absorption models, and also the adjustment of the amount of insulin that the system can give you as a percentage of basal rates and things like that.
Thanks, Tim. That's probably the most important thing to me is, you talked about earlier giving, a percentage of your bolus and then letting it handle the rest. To me, that works the best, even with auto bolus branch.
Mm-hmm.
But I suspect that free APS would work better.
Yeah, I mean, I've not tried it, so I can't comment on that.
Okay.
Anything else from anybody?
I have a question. What's the best way to switch from autobolus, loop autobolus to Android APS?
I would, if you're moving from any system to Android APS, I would recommend setting up Android APS to pull the glucose data from Night Scout and to run it as a virtual pump whilst you work your way through the the objectives, because the objectives take a little bit of time, and for quite a substantial period of that, you won't be able to close loop. So if you want to use closed loop, you'll need to continue to use your existing closed loop whilst you work through the objectives in Android APS before it will allow you to do that.
Thank you.
Hi, Tim. Can I ask, because I am an old-time user and I have kept my settings as they are, I'm still using ORAF 0, or I like to call it OLAF in homage to Frozen. If I am moving to OLAF 1, I will call it OLAF, is there anything I should be aware of that I have to look out for my settings?
One of the things that people find when they move to ORAF 1 and enable SMB is that they often need to adjust the carb ratio.
Okay, but if I'm not activating SMB immediately, because I would prefer to, do you know what I mean, test it out without adding too many variables at once, should I?
It works the same way pretty much.
Okay, no, that's great, thank you.
Somebody's asked a question in the chat, is CAM APS for UK only? I'm aware that there are a few users in continental Europe using it, so it will be up to where the local regulators have approved it for use. The MHRA in the UK has obviously signed it off. And there are clearly a few places in Europe which have also given it approval to be used, but I can't give you a list of that, unfortunately. You'd have to ask them directly. Just check through the questions. There's one there about, so Jess has mentioned about potentially flipping to Android APS. So this is something for everybody who is using DIY systems. If you move to either Android APS or Loop from OpenAPS, you do need a Riley link in order to have a Medtronic pump or an Omnipod pump work with the APS system, because they don't have Bluetooth on board and therefore need the translation for the radio signal. And of course, the other thing around Android APS, we've been discussing 2.6 versus 2.8. The key thing with 2.8 is it has a minimum Android level now of Android 8. 2.6 will still run on Android 7. So if you are looking, well, if you don't have an Android 8 Plus phone, then you can't use the more recent versions. And that's because of the changes in the underlying structure of Android as it has been upgraded.
Tim, can I ask you about Libre 2?
Yep.
And, you know, obviously I'm considering that as an option, but I'm just wondering whether I should use it with a Meow Meow or without. Do we know whether one way is better than any other?
So what I can say in terms of Libre 2 versus Libre 2 plus Meow Meow, I'm aware of a couple of people on Android APS looping with Libre 2 without Meow Meow, using the patched Libre app as the source of glucose data feeding into XStrip. There is also the OOP2 algorithm, so effectively you're using XStrip with the piece of code from within LibreLink that allows you to convert the data into glucose reading and forward that onto XStrip. The only reason you would use the Meow Meow with Libre 2 is because you wanted to be able to do a wide-ranging calibration with the system. There may be other reasons that other people are aware of, but certainly wouldn't be that would be the main reason I could think of. Personally, if I was using Libre 2, I would do it with the OOP algorithm and XStrip, or potentially the LibreLink patched app. The Libre Geeks group on Facebook is a good place to go to find out more about that.
Thank you.
One difference I could see with Meow Meow or anything that's going to scan the sensor versus the Bluetooth transmission is the ability to backfill data after you've been away from the transmitter.
XDrip actually has that now.
It can do that via Bluetooth?
Yeah.
Okay, thank you.
And Tim, I don't know if you know, but how would the Bluetooth kind of thing work with Loop? Because obviously I'm using Spike.
Yeah, nobody's done anything on that. The challenge with the iPhone is that you would have to get a modified version of the Libra Link app onto the phone in order to use it, because and I don't know anybody who's tried to patch the Libra Link app to make it work on iOS. Given the restrictions on iOS, I'm not even sure that it would work, quite frankly, because it would be signed with something that would cause issues for EOS with it. And Spike's pretty much not had any work done on it for 18 months, so it's not going to work with Libre 2 as far as I'm aware. So if you're using Loop with Libre 2, you're going to need to use a Meow Meow to feed Spike.
Okay. Yeah, I mean that was the concern that you know, I've been seeing people collecting their prescriptions and then all of a sudden getting Libre 2s, and of course, you know, for me, if it ain't broke, don't fix it. I you know, if that happens, obviously, as you're saying, I just need to kind of stick it in my arm and stick the Meow Meow on it as normal.
Mm.
Can the Libre 2 be calibrated without the use of a Meow Meow and XDrip?
In what, was you just using it as a CGM?
Yeah.
No.
So you're reliant on the fact that they're accurate and there isn't huge variations between the sensors then?
So the Libre and Libre 2 uses a factory calibration model. The Libre 2 and the more recent Libre ones are done on a a sensor by sensor basis. Historically, they were done on a batch basis, which meant that you had quite a bit of variation. If you're using, in order to turn it into a CGM, you need to use XDrip in there somewhere. And XDrip, you can calibrate the data that comes out of the Libre 2. If you're using Libre Link to produce that data, there is a maximum amount of calibration that you can apply. If you're using the OOP algorithm, I don't know if you have the same. Actually, no, the OOP algorithm doesn't allow you to calibrate. Historically, the OOP algorithm didn't allow you to calibrate when you were using it. It may have changed now that they have the Libre Link app calibration in there, but I haven't tested that, so I'm afraid I can't confirm it.
Okay, thanks.
I did want to make one comment based on a couple of things I heard people here say. One of the things that developers struggle with is getting people to actually update software. I think somebody just made the comment, if it ain't broke, don't fix it. I think everybody needs to remember that we're surfing on the bleeding edge of technology here, and settling into a comfort level and just staying there is probably not wise, because you're not at the most, this isn't something that's been tested by millions of people with every little last kink worked out. So when the developers find and fix a bug, updating to the latest is probably a good idea. I'll admit that personally, when like a 2.8 comes out, I would wait for the 2.81. But after that, it is definitely a good idea to keep up to date with the latest and greatest, because if you're using the old stuff, it's just not as good. This isn't, I mean, it is tried and true and working, but it isn't the same as something that's as tested as a million user application that's been out in the market for years. So, just getting comfortable is probably not a good idea.
That's a fair point. And if you look at the release notes for all of the various releases, you will often see stability improvements, bug fixes, etc., listed in those release notes. So worth highlighting that. Is there anything else that anybody wants to pick up on? Okay, if there's nothing else anybody wants to raise, I hope we've picked up on all the questions that people had that they were asking, and we'll come to bring this session to a close. I have recorded it, so I will try and make it available to access from Diabetic, and people can then come back and have another look at it. So thank you all very much for joining us today and for all the contributions that have taken place, and I look forward to seeing you all jump in and get involved in the various Facebook groups and social media and helping other people out with the with what you've learned from this session and getting things working through your own APS systems. So thank you very much, everybody.
Thank you. Thanks, Tim, for organizing. Bye.